you just do it, it'll turn out okay. And we're back with more Talking Time After Caffeine. We podcast where we do the caffeine thing. We talk about the world around us. You all know Jackson returning to us after a year absence.
Yes. I was on vacation, literally.
I met our friend Mr. Wilford.
Yep, hello.
You may remember him from our slideshow presentation of the geology, the big picture, and extinctions.
Yep.
He's a pretty cool guy. I like him.
And today we're here to talk about the Cretaceous, both its geology and its biology, which this other nerd here is going to handle.
Allegedly.
Oh, we have a comment already.
Good.
Uh-huh.
Well, who is it?
There's no such thing as a Cretaceous period. All animals from all ledge time periods coexisted all at once.
Okay, so we're going to ignore that person.
Okay.
All right. Moving on to the geology.
All right. You mind if I share my screen here?
Sure. One second.
It'll cost you, though, like $10. I don't make the rules. I just enforce them.
Look, I live in Florida. There's toll roads everywhere. I'm used to being
like nickel and
cheated
dime
out of my money. Yeah.
Right. Yeah, I believe it.
Yeah, you have any issues?
No, I'm good. We're ready to go?
I don't see the screen.
I don't see it either.
Okay. Hang on. Well, you said hang on, so I was just waiting. All right, there we go.
Excuses.
Cool. All right, how's that look?
Yes.
Good.
I see it.
All right, cool. So today we're going to talk about a little bit about Cretaceous geology to start with. So the first thing we want to do is define the Cretaceous period. And over here on the right, we've got a generalized chart of Cretaceous stratigraphy where it breaks down into... Now, this is a little oversimplified. There should technically be an early, mid, and late. But the ages over on the very far right are all correct. So the Cretaceous period is the final period of the Mesozoic era. And it dates from roughly, and the lower boundary is a little bit vague, so we'll talk about that in a second. But roughly, it covers about 80 million years, spanning from about 145.5 million years ago to 65.5 million years ago. And fun fact, that actually makes it the longest geologic period in the Phanerozoic.
Woo.
And the name Cretaceous is derived from the Latin word cretia, which stands for chalk. So
is this the chalk that we write on the chalkboards and the sidewalks with?
That's where a lot of it comes from, actually. Yes. But why do we name it after? Why is it the chalk period? Well, it's because during the Cretaceous, there were ample formations of chalk and marine limestones that formed, particularly across places like Europe. And right here, you got the White Cliffs of Dover. These are very famous over in England. And they're part of what is known as the chalk group, which covers southern and eastern England and then goes across the English Channel into Europe. And what's interesting is that despite these chalk beds, these chalk strata being the most infamous part of the Cretaceous, so much that we got its name from them, they're actually not what's predominant in the Cretaceous period. Limestone, actually, which is separate from chalk, is usually the dominant sort of marine sediment you see. And also, chalk itself is not unique to the Cretaceous period. We have chalk deposits outside of this as well. So when you're dealing with a geologic period, you have to define boundaries. And while with a geologic formation, for example, it's usually done physically, such as You know, if there's a very sharp, unconformable divide, like a sharp line between two different formations, it's usually easy to spot. In some other cases, there is no sharp divide, and the materials of one formation sort of grade into the other. And for those, you usually just pick the nearest landmark and just arbitrarily say, okay, that's where we're going to call the line. But when you're dealing with defining a period, physical traces are not usually enough to do it. You need an actual defined age. And so almost all geologic periods have a well-defined, solid date for the upper and lower boundaries. And what's interesting with the Cretaceous, though, is it's one of the only periods which doesn't have a well-defined lower boundary. Because there's no real extinction event or anything of the sort, or chemical anomaly or anything like that, which you could just point to and say, okay, this is significant. This is where we're going to start the Cretaceous.
How dare animals not die so we can know when it
Exactly. What's funny, though, is that the upper boundary of the Cretaceous is like one of the most clearly defined boundaries in existence.
Ooh,
because
it's
got this very, very well, easy to notice iridium-rich horizon across most of the globe. So, at the beginning of the Cretaceous period, the Earth was already experiencing a breakup of its latest supercontinent known as Pangaea. And this breakup would only get more dramatic as time went on. And right here, this little image I have is basically what the early Cretaceous looked like. You can see that, Europe and the Americas were starting to separate. South America and Africa were starting to come apart. The Atlantic Ocean was starting to open, particularly down in the southern hemisphere. And originally, these two land masses during the Cretaceous were divvied up into Laurasia in the north and Gondwana in the south. And the equator was pretty much dominated by the Pacific Ocean and then the ancient Tethys Ocean, which would disappear and either become part of the Pacific or merge into the Indian Ocean later on in Earth history.
And there wasn't really an Atlantic Ocean yet. It was like maybe Atlantic Sea.
As you can see, the Atlantic Ocean, the northern Atlantic, was sort of this smaller, closed-off sea, and then the southern Atlantic wasn't even fully open yet.
About what you mentioned earlier, the arbitrary line. Like what was actually used as the arbitrary starting point for the Cretaceous?
As the lower boundary or the
upper lower boundary, yeah.
So we don't know. We don't have a solid line. It's typically just placed around 145.5 million years ago, tying in with a specific change of microfossils, but that change isn't really a globally noticed thing because it seems to have just been a case of a lot of them dying off, but nothing really significant for most life on Earth.
So it's a bit of a historical quirk, like somebody just noticed something in somewhere, and let's draw the line there.
Yep, and if you actually check like stratigraphic records and community of professional geology organizations, they'll note that almost all of them can't really define with confidence where the Jurassic ended and where the Cretaceous starts.
So it looks like we have like an Atlantic Sea up north and an Atlantic River in the south. Basically,
it's shallow open, and it's basically the opening of the Mid-Atlantic Ridge is what's pushing this breakup of the continents. So right here we have a picture of the Middle Cretaceous, and you can see now the Atlantic's opening up, and the Tethys Ocean is getting smaller. You've had the Indian subcontinent has broken off and is starting to migrate northward. The Australia has broken off from Antarctica. And so as the continents... Oh, go ahead.
So this is more of a biology thing for Jackson, but it looks like unless you're flying, it looks like your speciation is happening here. Like you can't get across the ocean anymore to other lands.
Yeah. Well, organisms could actually pass relatively easily between different continents, and especially in that European area. And we'll talk about that during my part of the talk. There's a lot of archipelagos in the Mediterranean area where animals are island hopping between Africa and South America, there's still a lot of faunal interchange, and of course, we'll talk about that later. And same is true of in North America, even though you have those waterways, you still have crossing between the east and the west coast. But we'll talk about that later.
All right.
Speaking of the waterways, the rifting of these continents as they split apart actually had a major impact on global sea level during the Cretaceous. So, particularly as the Mid-Atlantic Ridge opened up, it caused this giant series of underwater mountains. And similar to how if you get in a bathtub, it raises the level of the water, same thing happens when you had the Mid-Atlantic Ridge open up. It displaced a large volume of seawater gradually as these grew. And
Are you saying I displace a large volume of seawater?
No. You're too scrawny and beta for that, Jackson.
Oh, okay. All right. I'm gonna make my way to Sigma male.
Shots fired.
You'll get to Sigma soon enough.
All right, good.
But as these seas gradually encroached upon the continents, and these are called epicontinental seas, you got, as you can see, like Africa started to have a large portion of its northwestern northeastern part covered in these shallow oceans. India was halfway covered, and then you have the beginning of the transcontinental seaway, the Midwestern Interior Seaway forming as the Arctic Ocean starts to push down into the North American continent. And these transgressions, as the sea level gradually rose, pushed these seas further and further inland. By the Middle Cretaceous, Australia was beginning to flood over a large part of its eastern and central area. The Arctic Ocean, again, started pushing down into North America. But it is important to note that despite the general global trend of a rising sea level, this rise was not even everywhere. Many factors contribute to the relative changes of sea level in a given area. So in some areas, you would actually have sea level relative to the land drop, even if globally it was rising, simply because, say, the land was having a lot of erosion at the time. And as you remove material from a continent, it's like taking cargo containers off a ship. As you remove that weight, the ship will naturally want to float higher. Same thing happens to the continents if you remove thick masses of rock. So for some local regions around the world, you did have drops of sea level, and you can notice these with like unconformities in certain areas. But the trend again was towards a global rise generally.
So a global flood is what you're saying?
Of course, yes.
Okay.
So now we get up to the Western Interior Seaway, which is one of the most famous epicontinental seas from the Cretaceous period, and I'm somewhat convinced this is just because it was an American one. And like, yeah,
America.
Yeah, Americans are very
America.
self-centered. That's just how
USA.
Yeah. So as you can see, eventually, this is from the late Cretaceous. This is what America basically looked like. Florida and most of the southern United States and the eastern seaboard is completely underwater. Most of the Midwest of the United States is also completely covered by this shallow sea. And then you've got two more mountainous land masses, which are Appalachia and Lauramidia.
Was this the Rockies yet, or not? They haven't been around.
The Rockies were starting to form around this time, and other mountain ranges around the same time.
Are these mountain ranges in Lauramidia also part of the Rockies, or not entirely part of the Rockies?
Some of them got eroded away, but some of them were part of the Rockies, yes. Or would become the Rockies.
Well, I know the Appalachians had been around for a while by now.
Oh, they'd been around for since the Carboniferous period.
Yeah, I went down there a few years ago. They're still pretty high, but they're not as high as some other mountains.
Yeah, they're only about 250 meters high, I believe, is what I last read about them.
Also, not as jagged, or at least not as high peaked. Like they have been eroded and also a bit smoothed out. I would suspect. Yeah.
And they've got very little sedimentary rock left on them. You're mostly dealing with the harder metamorphic cores of the mountains from deeper in the crust.
And James, RJ says Kansas beachfront property.
Mhm.
Yeah, Kansas was beachfront property.
And no Florida. Yay.
Oh, God, don't I wish. So, but what was interesting about not just the Western Interior Seaway, but a lot of the other of these epicontinental seas, was that this was where we got those infamous sandstones, siltstones, limestones, chalk beds, these thick marine rocks deep into the continental interiors that we see in the Mesozoic era. And what was more important is that you got lots of pulses of anoxia, which means low oxygen, during the late Cretaceous. And particularly in these shallow seas, they were stratified. So your upper portions of the water column would be fine. They'd have plenty of oxygen. Stuff could live just fine. But the very bottom would end up having very little oxygen, which is good for the preservation of organic matter. And so it's no surprise.
Is the reason why there was like high anoxia because it didn't circulate because it's
Yeah.
shallow. It's shallow.
Yep.
Too shallow for
Yep.
circulation. Right.
The shallowness interferes with circulation.
Hmm.
So, because of this widespread anoxia we saw in the bottom of these seas, it's no surprise the Cretaceous is where we get about half of the world's oil reserves from. Because of this widespread anoxia we saw in the bottom of these
Vernalia. Oh, is it?
How many Coltons are there? The world may
Yeah.
never know.
Yeah. No.
So, and the reason is this anoxia allows for the preservation of a lot of undecomposed organic matter, particularly marine plants and algae. As they build up and are buried by other sediments, heat, pressure, and time would convert them into oil and natural gas. And as right here, this is an example of marine shales from the Cretaceous period. And they're black because they're high organic matter content. And were these buried deeper in the crust, that organic matter could have been converted into hydrocarbons, petroleum essentially, and these would essentially serve as a source rock. They'd have the organic matter, which could then, through pressure and other tectonic forces, be squeezed out and put into pockets in other places around nearby to form like oil traps and seeps and things like that. But like all periods of the Earth, it has to end sooner or later. And we have one of the best records of how this period ended compared to most others. 66.5 million years, or 65.5 million years ago, we had a really bad day. A 10-kilometer wide asteroid hit the Yucatan Peninsula. And we know this because it left a 150-kilometer wide crater, which you can see buried under the sediments of the Gulf of Mexico.
Yeah. I mentioned this before, but it's good repeating. I did not know that this was so recent of finding and development. The thing, because thinking back about that, when I was when I was in the early, when I was growing up in the 80s and reading dinosaur books, this was not official yet. You know, the other theories about dinosaurs.
The Alvarez hypothesis only ever came around, I think, in the 1988. I think was when it was finally finalized.
Something like that. It was. I read or I was rereading a chapter of Dawkins' book, Climbing Mount Improbable, recently, and he mentions the dinosaurs and said, however they died, and I was like, oh, this must have been before times.
I remember the theories were like the mammals were eating their eggs and stuff, and books I was reading.
There was that. There was the idea that maybe there was some sort of pandemic that went through some of the basal food chain organisms.
They got COVID.
Yeah, maybe COVID made all the smaller ones die off before they could be eaten and overthrow the food chain. Or, maybe it was mass volcanism that had caused climate change and killed them off slowly. But now it's generally accepted that what was happening was that you had a series of gigantic volcanic eruptions that were causing climate change, that were sort of weakening the dinosaurs up towards the end. And had it not been for the meteor, they might have been able to adapt and pull out of that and, been just fine. But then we had the unlucky collision. It was a 1-2 combo, and 75% of all of Earth's species at the time died.
Recently I've also seen something interesting about the location at which the asteroid hit the Earth. Like, it was on a particular location where the rocks contains high amounts of sulfuric compounds, and that evaporated basically all of it into the atmosphere. So you have like a highly sulfuric atmosphere that blocks out the sun. Like, if it happened anywhere else where not much sulfur was present, then perhaps it wouldn't be as bad as it was.
Yeah, it was a really unfortunate strike, not only because of that, but I mean, even if you just think about the Earth today, right now with our sea levels at an unusual low relative to most of Earth history, we are 70% water, and that was higher back then because the continents were smaller due to the higher sea level. So realistically, it was almost, there was not an insignificant chance that this meteor could have just struck a deep ocean basin, and yeah, there would have been bad tsunamis, but it probably may not have, maybe wouldn't have led to a mass extinction.
Right.
But it hit shallow water, caused even worse tsunamis, and also kicked up all of that toxic debris from the strike. So really, really unfortunate day.
Also, did it hit in an angle? Maybe I've seen a paper that shows that maybe hit in an angle from the direction of like southeast and towards the northwest, basically.
And that's where we see the tsunami deposits angled towards,
yes.
Which we'll get to in a second, because there's actually a really cool site that was discovered back in, I think, just last year.
I do have a question about this event now. How come the name changed from the KT to the KPG?
So that's just a relic of changing terminology. So we used to call the early Cenozoic the Tertiary period, but then that got kind of vague, because if you just say, oh, the Tertiary, well, what part are you referring to? So they divided it up into a stricter, more well-defined series of periods, and PG just stands for Paleogene. So the Paleogene is the earliest period of the Cenozoic era, and
that's why the Paleogene, the Neogene, and the Miocene, I think, right? And then the Quaternary, if I'm not mistaken.
Yep. Yeah. Paleocene, Eocene, a whole lot of them.
Oligocene, Miocene, Pliocene,
You like Racco naming all the countries.
Right? Name every epoch in Earth's history. Jesus Christ.
Is this the flood layer?
Yes, totally. Actually, very interesting. Flood layer was left behind by this because of the tsunamis that it kicked up. Anyways, but what about the evidence of this strike? What made scientists think this was the thing that did it, and that this is where the Cretaceous ended? Well, first of all, we do have this massive crater found just off the Yucatan Peninsula in the Gulf of Mexico. But on top of that, we have a host of geochemical traces left in the geologic record, which indicate the meteor strike is what caused the extinction, and that extinction is what we use to define the end of the Cretaceous. So, aside from the meteor strike, the meteor crater, we have a layer of iridium-rich clay and other fine-grained materials which were deposited over most of North America and many other parts of the globe. Now, you don't actually see it globally everywhere you look, mostly because in a lot of places this boundary has simply been eroded away, which is unfortunate. But it's generally considered that most of the time when you look at this section in it where it's been preserved, you will see this iridium layer. And within this layer, we also have.
Do they found it in equal amounts, like if present?
It actually thins out the further you get from the strike.
Oh, that's an interesting pattern, yeah.
Yeah, and within this layer, we have diagnostic markers of an impact. So on the bottom here, you've got this quartz grain under a microscope, and it's got those etched patterns on it. Those are shock patterns, and they're only known to form under extremely high stresses and temperatures. And the general consensus of
what can be so stressful about a giant rock hitting you?
Yeah.
Don't they also form on nuclear like nuke test sites, like when they
nuke tests will do it, and the only other one event naturally that can make it are some really large supervolcano eruptions. But it's generally considered that the widespread nature of the shocked quartz within this boundary is far too widespread for a volcano to have been able to do it, which was one of the reasons it became one of the strongest pieces of evidence for a meteor strike. You also have up here on the top right, these are spherules. They're also known as tektites. They're essentially little molten blobs of glass that cool in the atmosphere as they're kicked up, and then they fall down as these little tear droplets of
cloudy with a chance of raining glass.
And again, these also thin out the further you get from the meteor crater, so that's generally considered diagnostic of a meteor strike. But they are still found almost across the entire globe, which is far too big of a range for any sort of supervolcano.
Yeah, that had to be a big. Had to be a big meteor. The evidence all around.
10 kilometers wide is bigger than. I think it's bigger than Manhattan. It's a really large. Ball of rock smacking us. And so, because it's at this boundary that we see so many species just disappear, and the boundary is so easy to recognize out in the field, it served as one of the best markers possible for deciding this is where the Cretaceous and indeed the whole Mesozoic ends.
Yes.
So, regarding this, I mentioned this interesting site that was found from this impact. This is called the Tanis site, and it's generally considered to represent the first few minutes after the collision. So, when you have a meteor of that size hit the Earth, it's going to send tsunamis, but the tsunamis take time to travel. The water is heavy, and it has to go over a shallow sea, meaning it's going to be slow. What will happen quicker is the earthquakes that go through the underlying rock. And those earthquakes traveled up through the continental interiors, and as you can see in this figure, the Yucatan Peninsula isn't even shown. It's way far down, but the Tanis site is found almost near the border of Canada. And within a few minutes, those shock waves traveled up the North American continent, and they basically stirred up these river systems and water and all this loose, unconsolidated young sediment, and caused massive sloshing debris flows. That then buried lots of fish and terrestrial creatures and plants, and all in this big jumbled mess that's about 9 meters thick.
And this Tanis, that's what the arrow was pointing to, right? On the chart.
Yes, that's what the arrow was pointing.
Yeah. Can they estimate like what the scale on the Richter scale it would have been like at that time? I would of course imagine at the impact site it would be like astronomical, but at this particular site, can they tell how?
I don't know what the exact figure is, but it's a safe bet to say that it would have made the infamous Haiti earthquake look like just some kid stamping his foot on the ground.
Even at the distance. Wow.
Yeah. It's a big force, and it's a certain type of shockwave that only forms from meteor strikes. So you don't have like continental earthquakes making anything comparable, just due to the nature of how that force is imparted on the crust.
Mm-hmm.
So would this have caused an earthquake hitting the thing?
Oh yeah, earthquakes would have shook the entire planet. One thing that's really interesting about the Tanis site, though, is if you look in the rib cages of the fish fossils, you see there are clusters of those little tektite spherules, meaning the fish in these sediments suffocated not just on the surrounding muck, but on debris that fell down within minutes after the strike.
So
That's whack.
You mentioned that the shock of the earthquake traveled to there within minutes, but also within minutes,
debris was kicked up and fell right back down.
Can you imagine?
Incredibly fast. Wow.
Suffocating on like burning hot glass.
Yeah. teardrops of glass.
Yeah.
That's still molten. It would be a
falling
horrible way to
from the
go.
sky. It is absolutely apocalyptic what the KPG meteor did to Earth, especially on our side of the world.
Like my
who's that?
first imagery of like the impact of it was like from the Disney's dinosaur movie 2000. You know, like they watched the impactor from a safe distance, quote unquote.
Right. No.
They couldn't even survive that if they were there. No.
There's a really good video by I always butcher their name. In a nutshell, that Curse Gazette or however it is.
Curse Gazette. Yeah.
Yeah. They
this
have
is the only
video.
time when my Dutch accent helps me.
Yeah. They have an excellent video, minute by minute, of what it would have been like to live on the Earth on the day that the meteor struck, and what would have happened. And
I think it's isn't there like as it fell through, you would have gotten like a view of outer space without atmospheric distortions for like a few seconds. So that would have also been neat. Yeah. Hey, look, stars.
And if you manage to survive the earthquakes, God help you when the global wildfires break out.
Yeah.
Yet once again, our ancestors survived somehow.
Well, they were tiny.
And they lived underground.
Yes. There's a really good book, The Evolution Underground by Anthony Martin, which is all about ichnofossils, especially burrowing organism ichnofossils. And so if you're into that sort of stuff, then check that book out. And he does talk about the mammals who survived in Cretaceous extinction.
Yeah, and paradoxically, it turns out that the survivors of birds were also like at least ground dwelling.
Mm-hmm.
So they weren't like of course they could fly in the but they were mostly ground dwelling. Like I think a good analogy is the tinamou, maybe like although better flyer than the tinamou, but still they're mostly on the ground. But yeah.
I don't know if you guys have read Last Chance to See by Douglas Adams and Mark Carradine, but one of the funniest lines in that book is about the kakapo. And he says, not only has the kakapo forgotten how to fly, but it has forgotten that it has forgotten how to fly. It will run up a tree and then jump off and then land on the ground.
I know the line, yeah, it's so funny.
Next time. I'll get it next time.
So there was one other thing that I know Lamont wanted me to talk about, and it was how did the different ages, if we go all the way back here, how did all these different ages here on the right get their name? Well, it's really not that exciting. Almost all these just refer to villages around the area that a particular scientist who was defining it was working out of.
Like
that's really it. Like
that's like in Germany, isn't it?
Yeah. And as you'll notice, a lot of them are German and French and a whole bunch of.
Although, as a Dutchman, I can tell you about one particular time period.
Go nuts!
It's the last one, the Maastrichtian.
Mm-hmm.
It's named after the village, after the village called Maastricht. But that's also named after the river called the Maas, which coincidentally is also the name the river from which the mosasaur gets the name, the lizard of the Maas River.
That's awesome.
Basically.
Oh, that's so cool!
Yeah,
I didn't know that.
Yeah, I was just wondering about these because beyond this point, like after this point, we start doing things by epochs and other periods and stuff like that, short periods of time. But before that, we go along millions of years, like in the Cretaceous period. We don't talk about these little small areas as much.
Mm-hmm. And they're also not defined by any sort of earth-shaking, exciting events. It's usually just turnovers and microfossil records and things like that.
Here's an ammonite. This ammonite no longer exists. Here's a different ammonite. This ammonite no longer exists.
Then you show them to any layperson and they can't see the difference until you put them under a microscope and say, see the little sutures on their shell? This one's at a 35-degree angle. That one's at 36.
Yeah, which is on the one hand, I mean, it's really funny because like that is actually how they do it. But also it's like that's microevolution, right?
Yeah.
In the fossil record, you're looking at it from
Yeah.
million years to million years. Like you can see these teeny tiny incremental
And
changes.
the fact that these incremental changes like almost never overlap with each other, even through very thin sections of the rock record, is an indication that it's not just variation within a single species.
Right.
Because if it was, they should coexist in the same
Right.
way that variations of different species today coexist and would be found buried together if you looked at rocks from our time period.
Yeah.
Right.
And that, it'd be like, and that 2-degree thing in shell size is why it's the division line between the Albanian and the Cenomian.
Yep. Essentially.
Well, I mean, because these terms are they're useful constructs, right? They are representing things that actually exist, which is for the Maastrichtian, it's like the time that the ammonite Pachydiskis newburgensis exists in the fossil record. But like that doesn't mean anything. It's just useful to us to refer to a slice of time as the Maastrichtian because we can talk about the KPG extinction event, and this is when Triceratops and Tyrannosaurus Rex lived.
And it's particularly important for oil exploration.
Yes.
Because they need to be able to target, when they're drilling underground, very narrow bands of rock to actually safely penetrate a trap of some sort without the pressure coming out and the whole damn thing exploding and killing everyone on the rig. So they need to be able to accurately define by very small changes in stratigraphy of microfossils or in ammonites or other things, particular tiny bands of rock. Otherwise, they're going to be putting themselves in a lot of danger.
Heck yeah. I think the tennessite is freaking cool, and I am waiting with bated breath for them to publish more papers on the fossils from that region, because they said in the press release they're working on a bunch of stuff, and so I'm just like, come on guys, let's get it out there.
I'm waiting for them to dig up like an actual dinosaur that's also like has scorch marks.
Well, because they claimed in their press release that they had found like feathered theropods and a couple other things and like drowned anthills and stuff. So it's like, yeah, let's get these out. I really want to see it, but I mean, I know these things take time, and
So before
Jackson.
So before the pandemic hit, did you ever go to these places to study these things in real life?
Oh God, no. I live in Florida. There's nothing interesting here.
Got sand, lots of sand,
lots of carbonates.
Yeah,
nothing interesting.
Also, you're probably familiar with the creationist song of millions of dead things buried in rock layer, laid down by water, all over the earth. Well, this particular example is not laid down by water. It was laid down by an earthquake triggered by an asteroid hitting the ground over thousands of miles away. Yeah.
Essentially.
Yep.
But yeah, that's that's all I have for the geology of the Cretaceous. So if we want to pass it on over to Jackson.
And round of applause for. We talked
You're
about
my favorite train guy.
Oh, thank you.
We talked about the thing we were standing on, and now we're going to talk about what we're standing on those rocks.
Right. Yep. Because the most important thing is the Earth itself, and then the organisms adapt to the geography of the land, and of course the geology affects the climate and all that fun stuff that also affects organisms. Can we see my screen?
No,
not yet.
No.
So maybe it's almost the next time. Oh, there you go.
You see it?
Yeah.
All right.
You can also make it bigger by dragging the sidebar all the way to the left. You know the tiny slides on the left.
I'll make it full screen. I'll make it full screen in a sec.
All right.
Okay, because I always have to jump out for some reason and then come back into it. I don't understand why. Okay. All right, as Colton said, and everybody.
No, it doesn't work. I think making it full screen.
You can't see it.
You can see it. Just
I make it, but not full screen. I think. No.
Well, it's full screen on my end. This is the largest I can make it. Are you guys seeing my slide?
We still see the original, like when you open PowerPoint like that.
Why is that? It should be saying the setting. That should be the slide up.
We see it. It's just we also see all the other around it stuff too.
Okay, can you click on the top right, but not on, all the way on the top right? That tiny arrow. Yeah, that.
Should have used
that-
Google
there you go.
Slides, bro.
That's a
You know what, Colton? I don't want to hear it.
yes. There you go.
Okay,
I think that's
so
better, right? Yeah.
this should.
Much better.
All right. So the setting, as Colton said, about 145 or 46 to about 65, 66 million years ago. I just rounded instead of dealing with the decimals because who needs decimals? And so you have a picture here on the top right. That is the Earth in the late Cretaceous. You can see the Western Interior Seaway, the archipelagos of the Mediterranean. We'll talk about those. And as we said earlier, Africa and South America were a lot closer. So a travel between them, even across the ocean, would take very little time, probably like a couple of days at that point. Because by 40 million years ago, when the Platyrrhines or the ancestral Platyrrhines were rafting from Africa to South America, that only took about 8 days or like 12 at most. So this is just a few days, or even this is less than that. So maybe even a day. So anyway, as he said, that was not really an extinction event. The beginning of the period was relatively uneventful. Continents are looking relatively like themselves. A couple of things I want you to take note of. He mentioned India. India is near southern Africa. So India was a part of Africa. It was part of Gondwana and then drifted up and hit Asia.
Yeah.
And
So
then
this
that's
is-
what...
Was Madagascar still connected to India?
Yes.
Oh,
yeah,
yeah.
at this in the late Cretaceous.
So
yeah.
this is about when it just broke away from Africa, give or take.
Yeah, it probably broke away a little bit earlier, but yeah, it's starting to drift up. As he said, the Atlantic Ocean is not an ocean; it's a it's a sea at this point. Asia and North America are still connected via the Bering Strait, land bridge. One of the things, there are a few climatic things which are changing. The world is a little bit less tropical than it was in the preceding Jurassic. It's getting a bit drier. But by and large, things are pretty much the same. You still have a lot of the same groups of animals that were around in the late Jurassic, which straggled into the early Cretaceous.
Although, wasn't there an extinction? Or maybe you will get to that point, but I hope I won't spoil anything. So,
Oh,
am I allowed?
You always spoil things, Nestle.
I will shut up then.
No, give it to us. What you got?
Like, wasn't there an extinction with sauropods? Like you
Oh my goodness, you're spoiling it again. There we go.
Real fast.
Yeah. Never mind.
I mean, I should have mentioned this during Colton's slides. It's more geology and biology, but this breaking up the continents happened like for a while, not under 1 year, right?
Correct. Yeah, this is starting in like the Permian, I think, or like
so.
Triassic. Colton, correct?
Yeah, that was when we started to see the beginnings of it starting to split up.
So you're saying it didn't happen in 2000 BC?
Well, clearly not, because we're still here and the planet isn't plasma. So
right. All right. The flora. You guys, I was only going to talk about animals. No, we're talking about plants, punks.
Yeah, because we did the whole series on plants. You got to mention them now.
Yep, exactly right. So the flora. So the really big change in flora is that flowers appear in the early Cretaceous. They just kind of appear, meaning that we're missing a lot. We're still missing a lot of the sort of early stages of flower evolution.
Yeah.
If you look at this,
I agree. Let you finish. Sorry, I will.
Oh, okay, that's fine. If you look at this guy down in the bottom left, Archifructus, it's one of the most basally derived known angiosperms, which are the flowering plants. We do have a couple of guys who are more sort of stemward, like Williamsonia, and they have some features which are sort of angiosperm-ish, but they're still missing a lot of stuff which are diagnostic of angiosperms. So there's still a lot of stuff missing from the fossil record.
Yeah.
Go ahead, Nestle.
But there was some recent papers on studies on genetics and also fossil data, and by combining them together, they say that it's very likely that angiosperms had a cryptic evolution before the Cretaceous. So they were there, but they were not very common, and that's why they aren't found in fossil record. But now in the Cretaceous, they are suddenly blooming.
Wasn't it the same with grass? That grass was kind of localized for a lot longer prior to the.
Yeah, probably. Yeah.
Yes.
Yeah, it wasn't until I believe like the Eocene or Oligocene, when grasses really just take over, like the forests start retreating by and large, and you have this huge opening of grassland. That's why we have horses with long legs and elephants and rhinos and all these much larger megafauna.
And grazing with
I guess it's easier to grow big when you're surrounded in grassland and not surrounded by trees.
Yeah, I mean you can get large.
And you need to see over it.
Right. Yeah, you can get large forest critters, but yeah, a lot of times it's you have a size constraint because you're trying not to bump into trees all the time. So you need these open areas. The fields of the Jurassic would have and the Triassic would have been largely ferns, which is a weird thought. It's weird to think about ferns being like the ground cover. So because they're so much reduced today.
Yeah, and also like the tall plants are mostly like gymnosperms.
Mm-hmm.
Right. Of course, until the angiosperms came around. Yeah. So although I think the angiosperms were at first mostly also ground, low lying,
little herbaceous plants.
Yeah, you didn't have trees angiosperms yet, I think.
Right. Yeah.
And was this the beginning of plants using insects to transport pollen instead of wind?
Yeah. So as Nestle mentioned, there was probably a lot of the evolution of angiosperms, which was cryptic, and part of the evidence for that comes from an event called the Cretaceous terrestrial revolution. So sort of at the very end of the Jurassic, very start of the Cretaceous, you get this big diversification event of one of the things is arthropods. Arthropods are preyed on by mammals, and the mammals have been preyed on by theropods. And so you get these sort of radiations on radiations because the food supply is radiating, and that allows for radiations up the ecological chain. And so you get all these big evolutionary events sort of occurring around the same time, probably because that's when flowers were really bursting onto the scene. You actually get the very first birds, late Jurassic. You get the first tyrannosaurs, like dromaeosaurs, all those guys, right at the very end of the Jurassic, which was probably when flowers and arthropods were starting to make their connections. And then in the early Cretaceous, you see the very first wasps, the very first bees, very first ants, because you had wasps in the Triassic, but now bees and ants and other lots of other arthropod groups are springing up.
Yeah. It's also interesting to know that what made the surviving bird lineages, like the crown group birds, those birds that survived were specialized seed eaters.
Yeah, it's like one group of wasps was like, hey, instead of attacking things and eating these living creatures, there's these stationary things here we can get food from.
Yeah, we talked about that in our video on the evolution of flowering plants, where bees probably ate arthropods, which lived on or in the flowers, and then because they were covered in pollen, this in turn caused the bees to like ingest pollen and accidentally start this coevolutionary relationship with flowers. So it was totally accidental, and now bees are the quintessential pollinator. So it's just kind of funny. Are we good on this slide?
I believe so.
Okay.
Yep.
All right, so let's talk about some aminals. So sauropsids, these are the lizards and snakes. So the cool thing about snakes is they are lizards who lost their legs. And if you look at this fossil on the top left, that's Tetrapodophis, meaning it's a 4-footed snake. It actually has all 4 limbs are just vestigial. It probably couldn't have used them for anything given how tiny they are. It's also got little teeny tiny fingers, which is so cute. And then Hastiophis, which is I believe a little bit later, has only the hind legs. The front legs have been reduced to nothing. And today the only snakes that have like even the vestige of limbs are the boids. They still have little they can have like little claws on their pelvis, which is external claws. It's the weirdest thing, but kind of makes sense if you understand how evolution works.
Yeah,
So.
and these claws are almost at the end of their body, so they're like snakes are almost all back, basically.
Mm-hmm.
Right? Not many tail. Mostly back, little tail.
Right. Yeah. It's
So on the right side, are these like the mosasaur ancestors?
Yep, these are the mosasaurs. This is sort of the evolution of mosasaurs, Aegialosaurus,
Yes.
and yeah, these guys are getting progressively larger. They're getting better at living a totally aquatic life rather than just being semi-aquatic. And then, by the late or sort of by the mid to late Cretaceous, you get really big mosasaurs.
Yeah.
And these guys, a lot of them are found in the middle of the United States. Like Nebraska, Kansas, because as we said earlier, that was beachfront property or it was underwater.
But the first one was discovered in the Netherlands by I think it was Napoleon who discovered the first mosasaur.
Yeah. They're a neat little group. They're either more closely. It's like they're either there's a little bit of debate. They could be monitor or sister to monitors or sister to snakes or basal to both. There's a little bit of debate over that.
There's a debate about it. Yeah. And there's also debate about the evolution of snakes. Like, did they evolve to be like they are because they were burrowing or because they were swimming? That's an interesting controversy.
Right.
So Jackson, were you then on the debate of that?
I'm not familiar enough with the sides. Whichever, I really honestly won't be surprised regardless of which it turns out to be, because I mean, it's either way, it's going to be like the mosasaurs are either within Toxicifera or they're right next to it. Oh, and snakes that probably were doing both swimming and burrowing. I mean, in all honesty, so I really won't be surprised whichever way the debate ends up. So.
I highly suspect burrowing, because whenever we see the same like body style with other animals, they are burrowing. Like, for example, the
Sicilians and
Sicilians, they are burrowing.
Yes. On the next debate channel, mosasaurs, were they snakes or monitor lizards?
That would be that is such a niche debate. I would be surprised if you get anyone to show up for that.
Would you show up, Jackson?
Maybe I'd have to make some popcorn, but maybe probably.
Well, at least for that one debate, it would be at least we know we'll know what side's right, and like all the same old evolution creationist debates.
Sure. No, I agree. Like, there are lots of very interesting debates within biology that I think should be platformed, but of course those don't sell. Like, I think it'd be interesting to debate the utility of the species concept, or was the Cambrian a short fuse or a long fuse explosion? There are lots of really interesting questions within biology, but those won't get you views on a debate channel where it's flat Earth versus someone who knows anything about trig.
Yeah, that was one of the most frustrating things. Like non-controversies are often published in like the journals, but the actual controversies are like almost nobody pays attention to them, except for, of course, for those who are interested in the
except the nerds.
Yeah, the big old nerds.
Yeah.
All right. Now we move slightly closer to the dinosaurs. We got Crocodilomorpha. Crocodiles were a lot more diverse in the past. Only a few groups made it through the KPG extinction, because it's not just dinosaurs who got wiped out. A lot of groups got wiped out by the KPG extinction, and a bunch of crocodile groups were some of them. You had running crocodiles, a few of whom like made it through, like Aeroreipasuchus, which is from South America. Armadillosuchus is a weird guy. It had this long, this long armor on its back. It was super weird. Sarcosuchus
also probably, I think also herbivores, right? Armadillosuchus.
I don't know about
Maybe.
Armadillosuchus. Chimerasuchus, though, I believe was an herbivore,
Hmm.
if I remember correctly. But yeah, there were herbivores, crocodilians, and omnivorous ones. Yeah, the hyper carnivore game was not the only game in town for crocodilians in
Yeah.
the Cretaceous.
Also a few. There were also like arboreal crocodiles and also like obligatory swimming ones. Like they never left
Right.
the ocean as well.
Right, like
Although we are
Metriorhynchus.
using crocodilian a bit loosely here, so crocodilian is the ground group, but yeah, it's crocodilomorphs.
So,
yeah,
yeah.
in any case.
I have to say,
Yeah.
I don't believe that. Like, if you guys live in the Florida and Louisiana area where the crocodiles live, so I bet you're glad you don't have ring crocodiles for you guys to live now.
Yeah, that would be horrifying. I mean, the Pristachampsus from the early Paleogene had hooves and ran after horses. Granted,
Yeah.
they were the size of dogs, but still, that's horrifying to think about. But at any rate, Sarcosuchus down there at the bottom left was actually 40 feet long, so that's another one that would be horrifying. Because the longest ones today are 22 feet, the saltwater crocodiles.
Were they the ones that could grab dinosaurs and eat them?
Yes, yeah, this would have definitely munched on some hadrosaurs or
I
iguanodonts.
don't know. I think the skull is not very robust enough to tackle big
fish?
prey. Maybe like large fish, perhaps.
I mean, 40 feet for some coelacanths.
Yeah, but there were very large fish around back then.
I guess I don't know. I mean, this is another debate.
Yeah, like Spinosaurus,
that's
also a fish eater. Yeah,
that's an extremely large crocodile because I live in Florida and I've gone to the Everglades multiple times, and more than once I've had to stop my truck on different back roads through the Everglades National Park because 20-foot saltwater crocs are laying across the asphalt, sunning themselves, and there's nothing I can do. I have to turn around. I have to go the other way because no matter what I do, that animal is not going to move. And it will just stare at you. So I could not imagine a 40-foot one just lying there and seeing one in person.
Yeah, that would be it's ludicrous.
That one probably could. That one probably try to eat your car that you're in.
I have to redact my statement. I made a quick look at Wikipedia, and it cited a study that shows that Sarcosuchus perhaps did eat dinosaurs. Yeah, so you're all right.
That's awesome. Oh, yeah. I mean, if you had told me that it was just a fish eater, I would have absolutely.
Yeah, of course. Always fact checking yourself. Just to be
always go to Wikipedia. Is the moral of today's story.
But I checked. They cite a study, so
I know.
I checked.
I know.
Yeah.
I know. All right.
Yeah.
Crocodilomorpha.
They're not just for kids anymore.
Are we good on Crocodilomorpha?
Yes.
Yeah. One question. These are like armadillos or like the ankylosaur versions of crocodiles. The top right.
I mean, I highly doubt that it would have balled up. And ankylosaurs definitely did not ball up. So it's probably just for defense against whatever predators were in its environment. And if it was in fact an herbivore, then that would make even more sense that it has this big armor.
Yeah, it's also. I think the armor is differently constructed. I think the armor of armadillos is more like tough. Like, is it tough skin or is it a hair or maybe like the scutes of crocodiles are bony, bony scutes. Yeah.
Yeah.
So it's not the case with armadillos, or is it? Yeah, are they bony scutes in armadillos?
They're tough, but I do not think they're bone.
No. Cliptodons maybe they have.
But we definitely have fossils of this back armor thing.
Yeah. We have with the fossils. Yeah.
Of the armor, we have fossils of the armor on this guy. That's how they know it what the shape was. But yeah, it's a weird dude. I think he was also from South America. South America had a lot of weird crocodilians in the late Cretaceous. They were going crazy.
Well, that's also where the marsupials had their start from too, wasn't it?
Well, there's Cynodelphus from China, but yeah, they kind of bottlenecked there in South America. In the like early Cenozoic, and then they spread across Antarctica and then into Australia. So yeah. So okay. All right.
So probably had to avoid those crocodiles.
Yep.
And our next closest cousin.
Yep, the pterosaurs, and so just a smattering of pterosaurs here. Tapejara, if you've seen the old, it's not old. Walking with Dinosaurs. This was featured in their episode on Ornithochirus, I think, which was another pterosaur. These guys are super weird. Just look at that crest. That was probably for sexual display. Who knows what color the skin would have been around it.
Big nose holes.
Yes, yeah, big nasal cavity. Just look at that.
Like you might, or some might think that those are like end orbital Vernestra, but no, those are actually the nares, right? Those big holes. Yeah.
Could you imagine and something I wonder now, just thinking about it, is like, do you think? And I have not seen this in paleo art, but like, what if it was like frigate birds, where they expanded the skin around the nares as part of like some sort of display? I don't know what the plausibility of that is, but I think I put it on the table right now. Could they have done that?
Maybe.
Like a frog.
Like a frog, yeah, exactly.
I have a question about the pterosaurs real fast.
Okay.
How did the elephants get higher up the mountains than the pterosaurs did during the flood?
That's a real good question. Another pterosaur we have down here is Tupaxwara, or I'm not entirely sure how to pronounce that. Regardless, it has a really cool.
Maybe Tapejara.
Tapejara could be, yeah. I was looking through pterosaurs, and this guy has a super cool crest, in my opinion. Then Hatzegopteryx, which, by the way, if you're wondering, that's as tall as a giraffe. And I do know a little bit about Hatzegopteryx because I'd write an essay for my dinosaur class last semester, and I did the whole thing on Hatteg Island, which was an island in the Mediterranean, or it's in present day Romania. And this islands have really interesting fauna because it had tiny dinosaurs, but super gigantic pterosaurs. And so,
of course, the tiny dinosaurs are relatively tiny because some of them were still the size of cows. But yeah.
Well, yeah, I mean, but yeah, you have like sauropods the size of cows rather than gigantic sauropods.
So were these things eating birds in the sky out of the sky?
Possibly. They probably would have been like fish eaters or insectivores. They probably would have eaten whatever they could get their hands on.
I didn't think birds were dominant in the sky, at least.
Now, Jackson, am I right to assume these guys would have pretty much almost exclusively used thermal circulation for to gain elevation and things like that?
Probably.
I thought I've read that somewhere that they weren't really
dinosaurs,
powered flyers.
I mean, dinosaurs had a bunch of them were like warm-blooded and.
He means like a updraft, like thermic updraft to conserve energy.
I'm sure. Yeah.
Yeah, but these guys mastered flying way before dinosaurs did.
Yes, yeah, they were first flying around in the Triassic, and at present, there's still a whole lot of debate over what the origin of pterosaurs was, because their fossils are so light, so they really don't fossilize well. Finding pterosaurs is actually extremely rare in fossil deposits, and the fact that we have so many is a stroke of luck. The fossil genie shines bright on us. But yeah, I think one of the presumed relatives of pterosaurs, which is a Lagerpeton, is now, I think they've moved it down. No, was it Lagerpeton or Lagasuchus?
Lagerpetits, I think, right?
Yeah. So, but they moved it.
Yeah.
They moved it, didn't they? It's no longer like a pterosaur relative, right? It was a jumper, wasn't it?
No, I think it first was like a dinosauromorph, but then it got to be a stem pterosaur, and at least according to one study. But yeah.
Right, that's where it was moved, but I think they moved it again, didn't they?
Yeah, really? I don't know. I haven't seen that. No.
I think it's considered no longer a stem pterosaur, which I was sad about because now we're back to square one with the pterosaurs. Yeah,
I do have another question about pterosaurs. We know that some birds lost the ability to fly and became ground creatures again. Any pterosaurs that did that that we know of?
Not that we know of.
Hatzegopteryx is huge, and I do wonder about that.
I have seen papers by Mark Witten that argue that pterosaurs had very different biomechanical makeup than birds.
Sure.
So you can't really compare birds, the flight with capabilities with giant
Sure,
pterosaurs.
right. I mean,
yeah.
they were quadrupeds on the ground. Birds are strict bipeds. You know, they're
Yeah. Like one of the main differences is like birds, they launch off the ground with powerful legs and they fly with their front limbs. But pterosaurs, they launch with their front limbs and also fly with the front limbs. So they use their like big muscly arms for both takeoff and flight. And that is a constraint they don't have compared to birds. Like birds have very heavy landing gear, and pterosaurs have basically wings and landing gear into one.
Did they have
same structure?
Did they have hollow bones like dinosaurs and birds did, or
Yes.
they were more?
Yeah.
Okay.
Yeah, it's also
the
like,
pneumaticity.
Yeah. It would be terrifying to live around at that time with giraffe-sized things like that. Like do you know the scene from Finding Nemo where they get almost swallowed up by a pelican?
Oh, yes.
Mine.
There was a paper I read on Hatzegopteryx where it is posited to have fed like a gigantic crane. So if you can imagine a crane or a giraffe-sized crane feeding on dinosaurs, attacking like
horrific.
cow-sized dinosaurs, it is ludicrous to think about.
Yeah.
Absolutely ludicrous. Featuring Pitbull. So anyway, all right. We get on pterosaurs.
Yes.
Yep.
All right. So the sauropods, as you mentioned, sauropods. Most of the groups of sauropods are the ones who kind of straggled to the end of the Jurassic, like the Diplodocus and the various macronarians. Most of them did not make it very far into the Cretaceous. They made it like sort of into the early Cretaceous, and then not very much after that. The Titanosaurs, which appeared in the late Jurassic, they spread all over the place. They most of them, I believe, are found in South America, but they also crossed into Africa and Eurasia. They're just all over the place.
Yeah, the Titanosaurs were like the last dying gasp of the very, very impressive gasp of sauropods. Yeah.
Yeah.
And luckily there were no meeting that we know of sauropods.
Yeah.
No.
As far as we know, except like there's
the very early sauropod morphs.
Yeah, like Buryolestes, which is one of the very first sauropodomorphs, may have been carnivorous, which is also not surprising given that Eoraptor, Coelophysis, the Silosaurids, everything was carnivorous at that time.
Yeah.
But
so I do a question about that. It's only going one way or both ways. Do herbivores branch off of meat eaters, or can they go the other way too?
I'm sure it goes back and forth with reckless abandon.
Regardless. Animals are on default carnivores because they don't have an inherent way to digest cellulose,
Right.
But then some acquire the bacteria to help them along the way to be herbivores. But of course, but there are actually some herbivores that went back. For example,
apes.
Psylocaleo went back to being carnivores.
Or
marsupial lion.
Yeah, you're absolutely right. Apes are another example because our closest relatives have a much higher proportion of their diet, which is plant material, compared to us, and we switched back in our hominin history to a larger proportion of meat. So it just goes back and forth depending on your environmental conditions.
Also, there are also many herbivores that also eat occasionally meat, like
like cows.
I think there are actually squirrels who gnaw on bone for the calcium.
So you're saying the animals adapted to their natural situations.
Correct. Yes.
Right.
What's that called?
Adaptation. But there's a video that horrified me the first time I saw it. It's of a cow eating chicks, little baby chicks.
I've seen the same video. It's horrifying.
Like the very first time I saw it, I was scarred, and then I watched like deer like licking the carcass of another deer after that, and I got kind of used to it, but like just the sight of a cow eating a chick, I was like, oh my God.
I want a reaction video of a vegan reacting to that video.
That would be very funny. Yeah.
Yeah.
We should send it to like Alex O'Connor or something like that.
No,
Or
when I was
raw Matt, maybe. Or is he,
Oh no.
or is he a vegan? I think he's vegan, right?
He's a
Or maybe-
breatharian.
Yeah.
He's
Yeah.
breatharian. That's even better.
Now, when I was growing up in the 80s, there's all these videos and pictures and books about these big sauropods living in the water.
Yeah, that's wrong. There's
Oh my
like
God.
1 or 2 people who I think still try to promote that, but
Yeah,
it's indefensible at this
there
point.
is one person who proposes the sex lake hypothesis, like dinosaurs
Right.
required lakes of water to reproduce, and then they also propose that the drying up of the lakes caused the extinction of dinosaurs.
Yeah, which is
Yeah.
just bonkers. Just bonkers. So the sauropods, the titanosaurs that you see here. Oh, so for reference, Macronarian is the group that also includes Brachiosaurus. So that line they were the last sauropods. The Saltosaurus and Argentinosaurus, both from South America. Argentinosaurus was freaking big. Like the estimates for how heavy it was are shocking. Meanwhile, Magyarosaurus was from also from Hatteg Island, so it would have been one of the cow-sized prey items for Hatzegopteryx. Just think about that: a pterosaur feeding on sauropods. It's truly amazing.
That could feed you for a while, probably.
I mean, you have also like a similar situation on islands in modern times. Like, for example, there's a meat-eating parrot who eats sheep. They eat sheep.
Yeah. The world biology is crazy. It's just nuts. There's a lot.
Also,
of
the sizes were ridiculous. Like you're not talking about elephant size. You talk about herds of elephants sizes.
Yeah, there were also in the Mediterranean later for a different reason. Lots of miniature elephants in the Ice Age, or sorry, not before the Ice Age, in the Messinian salinity crisis. You get the draining of the or the drying up really of the Mediterranean, and then when it rose again, a bunch of different mammals were stuck on these islands like elephants, and they got really small. So
We'll save that talk for more of that when we get to that episode later on.
mini mammoths. All right, so in that case, are we good on titanosaurs?
Yes.
All right, the iguanodontians. So this is a fairly famous group. Iguanodon is one of the first dinosaurs ever named or described, and it was one of the 3, along with Hylaeosaurus and Megalosaurus, which made up Dinosauria. So Iguanodon, Oranosaurus was from I believe North America and Europe. And then Oranosaurus was from North Africa. It was from sort of the same or similar area as like Spinosaurus, which is really cool because they both had this big sail for thermal regulation, probably on their back.
So these pictures were more of a quadruped than biped.
Yeah, they can switch back and forth. If they needed to like run, they would probably lift up their front limbs and book it on their hind limbs.
Yeah. Although maybe the very larger ones were not able to do that, perhaps because of the weight.
Right.
Yeah.
Because I remember, again, in the 80s when I was growing up, all these pictures of them standing on hind legs with like little thumbs up all the time.
Yeah, they could probably. Yeah, like most of them could probably switch back and forth, but yeah, some of the larger ones would probably have been just quadrupedal. Muttaburrasaurus is an Australian dinosaur. You don't hear about them a lot, but I wanted to include them because it's a pretty well-known iguanodontian. Also featured in an episode of Walking with Dinosaurs, where in the polar episode, which weirdly enough in that episode they say like the polar Allosaurus, which was not a thing because Allosaurus was long extinct by that point.
Are they talking about like Cryolophosaurus, maybe? It's
no, Cryolophosaurus was also early Jurassic. I think it was I can't remember, but I read something somewhere that described what it was or gave the genus of it. And I think there's a book that goes with Walking with Dinosaurs that also explains what it was. But I was like, I don't know why they use that term or that name instead of what it
was
was.
it like a Velociraptor in Jurassic Park? Isn't a Velociraptor like it's
Right.
Utahraptor? I don't know.
Yeah,
Right.
makes no sense.
So, going back again real fast, between Jurassic and Cretaceous, is that the only period that didn't have an extinction event between it, or then how do we know how that period, when that period ended, and when that other period began?
Well, it didn't have any.
It's one of the only ones that doesn't have any real extinction between. That draws the line between the two periods.
Yeah, because there was a big extinction event at the end of the Triassic, as the start of the Jurassic. That was what displaced the other Pseudotsuchians, because we're not even talking about crocodilomorphs at that point. We're even broader than that, and they were sort of the big, the dominant land predators and herbivores. Weirdly enough,
Oh no,
and,
actually, the dominant herbivores were already sauropodomorphs. They were already dominant as the herbivores in the Triassic.
By the late Triassic,
Yeah.
But you had like Adasaurs before then.
Yeah.
But yeah, so you had like these Pseudotsuchians, and they were at the very least the dominant predators, like Postosuchus and Rauasuchus and all those guys.
Yeah.
And then the Triassic-Jurassic extinction event wipes most of them out and leaves the crocodilomorphs, and then the dinosaurs essentially refill the niches. And we talked about that in a video titled Stasis on our channel. So if you guys want to know more about that, go check that out. Haha. Are we good on this one?
Yeah.
I do want to say iguanodontians were sort of similar to in that same thread of not much changed. Iguanodontians were a big part of the fauna in the late Jurassic, and they continued to be a large part of the fauna through the Cretaceous. So that was.
I think also hadrosaurs are they also part of Iguanodontia, or are they a sister group?
So,
yes.
So
that was within Iguanodontia. Then you have Hadrosauroidea.
So were these the two main divisions of like what they called bird hip or lizard hip dinosaurs? Which were these?
Yeah. So these. Oh, go ahead, Nestle.
These are I was saying these are the ornithischians.
Yeah. These guys are the bird hip. So funny enough, the sauropods and the theropods, with the exception of the later theropods within like Maniraptor, are they're the saurischians, right? They're the lizard hipped. The ornithischians probably have the bird hip as a result of having such a really long gut, because they're all herbivores. But the sauropods, if I remember correctly, sauropods had their guts out to the side, which is why they didn't have the.
Oh. So sorry for the interrupting. There was actually a recent paper that showed how breathing in ornithischians works, and it also has to do something with their pelvis too. Yeah.
Mm-hmm. Yeah, and so so they had the ornithischians independently had this quote bird hip with their ischium and pubis point backwards as a result of probably a number of different systems, including their digestive. But the sauropods didn't. They had the quote lizard hip, and the theropods up until you get later when you see like the therizinosaurs and the dromaeosaurs, they later reinvent the bird hip, and then that's what birds have today. So Hadrosauroidea, these guys are some of the earliest relatives of hadrosaurs. So as Nestle said, within Iguanodontia, we have the hadrosaurs. These guys are one of the things which makes hadrosaurs unique is they have this like dental battery, and that makes them super efficient chewers. And
they also had like very movable joints within their skull that allowed them to really like grind down the plant matter in every single stroke. Like every single stroke is like huge to grind down the plant matter. It's really like nothing in mammals even compares to that.
Right.
So what kind of plants do these things eat anyways? Do we know?
What kind of plants? I mean like lots of things. Ferns, ferns probably would have made up their largest proportion of their diet, but also probably early angiosperms, as well as maybe smaller gymnosperms. But yeah, they
Yeah. Also,
Plants, various plants.
I've also seen a presentation that showed that also wood was also present in their guts,
Sure.
basically. Yeah. So maybe they
Sure,
also it's they ate everything, basically.
Yeah, they're big herbivores, or and so they're just getting what they can. They're eating
Yeah.
everything in sight.
And
Yeah.
trying not to get in themselves.
Yeah, also,
Pretty much,
like,
yeah.
also to be specific, the dental battery is basically like a constant replacement of teeth, like no gaps, and at no point in your time, like when crocodiles replace that teeth, you have often one gap, and that is slowly refilled by a second tooth. But then it's just a constant series of teeth growing and then being how do you call it again?
It's just being replaced, and like they're
eroded.
all
It's continuously eroded. Yeah.
right. Yeah, it absolutely, and so
So which continent are these? Are these over the Earth, or are these more of a certain continent area?
well, these guys are in different places. Talmatosaurus is who's also from Hatteg, so he was another sort of dwarf dinosaur. Equidubus, I believe, was from China. I don't remember about Probactrosaurus, but they're probably Eurasia. I believe it's Eurasia was the origin of hadrosauroids, and then a bunch of them shifted to. I think most of them went to North America, or a lot of them went to North America, and so you sort of get this growth from Eurasia into North America, and then a bunch of them radiate there. And I don't think very many of them have been found in Africa, and I don't think any of them have been found in South America at this point. So it's mostly Laurasia is where the hadrosauroids are coming from. And that brings us to the more derived group of hadrosauroids, the Hadrosauridae. And so a bunch of these are from North America: Maiasaura, Corythosaurus, Parasaurolophus. Those are all North American, and you get these really interesting crests. So there was some
like the iguanodons. They operate in the Jurassic, right? But the heterosaurids, did they appear also in the Jurassic or Cretaceous?
Early Cretaceous, I believe. I think it was early, sort of early to mid Cretaceous is when the hadrosaurs first break onto the scene. Centausaurus was from China also, I believe. But yeah, they have all these really cool crests, which some of which probably made noise, like Parasaurolophus probably made noise with its, but Corythosaurus probably not. So there was some really interesting sexual selection stuff going on that we only get to see bits and pieces of 65 plus million years later. So
I probably had to do with like species recognition. So also, you can see like, oh, that's my species, and no, that's not my species. Like, yeah, of course,
right.
species. It's.
So are we good on this one?
Yeah.
Okay.
Yeah. So well, actually, real fast.
Uh-huh.
Back that one fast. Are these the dinosaurs, the crest that they were saying that they breathe fire breathing skills?
Yes. Dwayne Gish said
Parasaurolophus
could breathe fire, which is just bonkers. It doesn't even deserve rebuttal, just to be laughed at.
Didn't Ken Ham claim that Sarcosuchus could have had a compartment in the Sarcosuchus had like a big nose at the tip, right? Sarcosuchus, and he said it could have maybe housed a gas compartment or something like that to house the fuel for the fire.
Gas. It doesn't matter. We don't have literally anything that has flammable gas that it shoots. Like nothing, literally nothing organic does that. And so the fact that they think that a dinosaur would have done it, when we're like, it's just a nasal cavity, that's all it is. Why do you think this would have been fire? What do you think? Elephants should breathe fire? Like what the heck?
They probably either sexual purpose, sexual selection, or maybe something like that. most likely. I'm thinking.
Yeah, absolutely. Yeah, it's just it's absolutely bonkers. But yeah, ugh. And
Moving
you know
on.
the funny thing about I'm sorry, I just gotta say this one last thing. The funniest thing
Oh,
about
sorry.
the dinosaur fire breathing thing is Dwayne Gish never even attempted to support it. He just said, "Well, the bombardier beetle shoots toxic fluids." Granted, but that's not fire, so no. Anyway, moving on. Ankylosauria. So these are the big armored dinosaurs. The very first ankylosaurs appear in the late Jurassic. So you see like the very first ones in the Morrison Formation. There are like I think
The
Gargoylosaurus.
sisters didn't make it, unfortunately.
Do what?
Their sisters didn't make it, unfortunately. Their sisters, like the stegosaurs.
Right. Yeah.
Yeah,
The very first, or the very last stegosaurs, like Werosaurus, or however you
Yeah.
pronounce that, only made it into the very early Cretaceous.
Yeah, that's the thing. I didn't know until recently. Was reading Aaron Raw's series video that the stegosaurs and ankylosaurs were that closely related.
Yeah, so if you look at their earliest relatives, like Scutellosaurus and Solidosaurus and Emosaurus, the really cool thing is these are like getting progress. Like first of all, Scutellosaurus is
Bipedal. Yeah.
it's bipedal. Yeah, it's bipedal, and it's got all these little scoots on its back, and then you have
It's like a little armored velociraptor. Imagine
Right.
a velociraptor basically, but of course not as
right. It was an herbivore.
not as many teeth, of course, but still it stood up like with its hands up off the ground. But yeah.
Yeah, it's wild. You have these little bipeds with armored scoots running around in the early Jurassic and mid Jurassic, and then you get like Emosaurus, which is quadrupedal and has much more pronounced scoots on its back. And so what you can do at that point is you can either do what the Stegosaurs did, which was they really just expressed the ones which were going down the back, or you can do what the Ankylosaurs did, is you keep all of them and or express them differentially along the back in different ways. Like you enlarge the ones at the shoulder, but make the ones at the hip smaller, etc., or vice versa. And so yeah, it's just a matter of enlarging certain scoots along the body and the tail. And so that's basically what they did. It was it's really neat. It's almost like they're transitional or something.
Yeah, it's also interesting. Like some ankylosaurs even had bone covering their eyes. Like the eyelids were also armored, basically. So yeah.
Yeah, they're just so bony. They're just tanks, which is funny. Because there was an ankylosaur which was discovered a few years ago called a Borealopelta, and the cool thing about this guy is it had counter shading. It was so well preserved. It was actually preserved with counter shading, meaning it was preyed upon and needed camouflage, and that's cool.
Yeah.
You know?
Like I have seen a recent funny meme that shows like an ankylosaur watching a group of ecliptodons, and it says like, "Look what they have to do just to imitate a fraction of our power."
Oh yeah, the invincible meme. Yeah. That's so funny. But yeah, ankylosaurs are pretty neat. You have two different groups essentially of like the Nodosauridae and Ankylosauridae. Nodosauridae doesn't have the big tail club. Ankylosauridae does. So Seychania and Ankylosaurus both have that. There was a cool video put out by PBS Eons on the origin of the Ankylosaur tail club, and if you haven't seen it, you should. It's real neat because it's an example of a evolutionary prediction that was confirmed. So, whoa!
Yeah, I think probably one of the few dinosaur reviews of them I haven't seen. Remember seeing.
Yeah, it was a cool video. I enjoyed it.
So where were these? Where were these from?
Ankylosaurus and Ankylosaurus was North America. I think Nodosaurus may have been Europe. I think, and then Seychania was Asia. I believe mostly China.
So still the Laurasia area up north.
Yeah. Yeah. Still a lot of Laurasia, and when we get to theropods, you'll see even more stark the contrast between the faunas of Laurasia and Gondwana. But yeah, a lot of this kind of comes down to Gondwana and Laurasia, different fauna and not much exchange, because you got like the Titanosaurs were mostly Gondwana. They start out Gondwana, and then later you see them drift up into Laurasia, and then they spread up there. I believe iguanodontians were in both Laurasia and Gondwana because they've been around since the Jurassic when all the continents were more smushed together. But yeah, I believe ankylosaurs were mostly Laurasia. So are we good on this one?
Yes.
And now for a group which is quintessentially Laurasian, is the Ceratopsians. So this is the group with the horned face. If you want, so the cool thing about this group is the Ceratopsians, the big horned dinosaurs like Triceratops, their next closest relatives are the Pachycephalosaurs. And really the difference between them is both groups had a bony shelf at the back of the skull. The question is just, where do you express it? Do you express it more over the head, or do you express it at the back of the head and create a frill? And that's the difference really between between the Pachycephalosaurs and the Ceratopsians. It's just, where do you express the bony shelf? That's really it.
The two groups are grouped together into a bigger category called marginophilia, right?
Right.
And that basically means margin
on the skull.
On the skull, yeah.
Mm-hmm. So Psittacosaurus is one of the earliest examples. Then you have Microceratops. So the cool thing about Microceratops is you are starting to develop this little frill, but it's still bipedal. And then by Leptoceratops, you're starting to kind of teeter. A little bit bigger body, larger frill, and you're teetering sort of between quadruped and biped. And then by the time you get to Protoceratops, they're still relatively small. Like I think they're about the size of a sheep, but you've got a much larger frill. Still no horns, but your frill is much larger, and so you're entirely quadruped at this point.
And these are like some of these are Jurassic, right? Or are all these Cretaceous?
I think the only Jurassic ceratopsian I can think of is Yinlong, which also looks like Psittacosaurus. But I didn't represent him here. Yeah. But yeah, that's like very latest Jurassic.
Also interesting, we actually know how Psittacosaurus looked like from his impressions of his skin, right?
Yeah, this is the example I chose there. Yeah, that's the one that we actually know what colors it had. Those were its colors. It's that well preserved.
So would the Microceratops be the dinosaur that Noah took on the Ark since it's so small and stuff?
I think all these guys were like either a sheep or smaller in size, pretty much. The really big ceratopsians didn't come until later in the Cretaceous.
Yeah. Since they had to take small animals to fit them all.
I mean, he could have just taken Luca with him. Only one little microbe, and then everything comes from that. So
keep it in a petri dish, and that's it.
Exactly. Keep it in a petri dish.
Made of wood, and that's it.
Yeah, that's awesome. I love it. Okay, so Protoceratops. So still no horns, but we're dealing with quadrupeds. But as you progress through the Cretaceous, you get these really elaborate frills, and you get horn developments, which probably were both sexual selection and for protection, and so you get this big variety. Some had little horns, some had long horns, some had these really tall frills, some didn't.
Some had like 20 horns apparently, or
some had a whole bunch of horns on their head. They're just all over the place, horns galore. These
epiparietal and episquamosal bones, basically. Yeah, it's the tiny ones that are on the rims of the frills.
Mm-hmm.
But the main ones are either on top of the eyebrows or in the middle of the nose, right?
Right, exactly. Yeah, and so I actually know someone who went to the unveiling of the Diabloceratops skeleton, which I think is neat. But it's just a cool looking guy. Just like the two horns at the top are really cool.
Sure. Are these horns like say the antlers of deer, or more like the tusks of elephants?
I believe it's bone. I think it's
bone. Yeah. Like the tusk of elephants is teeth. Like
right.
It's not,
they're incisors. Yeah.
Yeah. So this would be bone. Yeah. And it was covered with a keratinous sheet. So yeah, it's more like. I think it's more like, maybe more like cows, because it's more of a smooth sheet, like they branch, the antlers branch, but they of course did not branch here.
Colton, you know what I should have done?
What?
I should have had a picture of a buffalo here and put like Triceratops under it.
Yeah.
I should have done that for good old Mark Armitage.
Oh.
Anyway, so I picked, and so there's a really cool paper that came out a year or so ago. Yeah, last year. The evolution of frills and centrosaurines. So here we have another like micro evolutionary series of events. If you look at the very bottom and you work your way up, so these are the way it's arranged. The way these strata are arranged it's chronological, and so you've got Styracosaurus at the very bottom. It's got what is it? The P4, I think. Yeah, P4s are, or no, I think it's P3s. Yeah, the P3s are elongated.
And I think that means parietal, right?
P4s.
Parietal.
Yeah. Oh, I'm trying to figure. Yeah. Okay, P4s. No, sorry. Yeah, the P4s are long. You just have the middle, the horns. You have the horns on top, then the horns on the side, then the ones on the very bottom, and so you have these sort of long middle horns, and then as you go a little bit further in time, then you get to Stegosaurus, and you've completely shrunk the smallest horns, the ones on the bottom, and the middle horns are much smaller. And then as you get to Enosaurus, you've almost entirely shrunk those middle horns. And then the cool thing is, by the time you get to Ankylosaurus, you're starting to curve. They're curving outwards, very very subtly. And then as you get to Pachyrhinosaurus, the very latest, they are really curving out there. And so you have this very this microevolutionary series where you have this reduction in horns and then this curving of horns, and that's all probably related to sexual selection. But funny if a flood happened, so whatever.
Speaking of that, Jackson, we have a question. They want to know if you know about the Inca stones that were created thousands of years ago.
Oh, the Incas. Oh, the Ica stones. Yeah, those are also dumb. Don't buy into those because
don't they also have like ancient astronauts on them or something?
Yes, they do, and cockatrices and dragons. So yeah, if you say I take the humans with the dinosaurs, you also have to say ancient aliens and cockatrices are real. So
you mean they weren't created thousands of years ago?
I mean, all I'm saying is you got to pick your battles. If you're going all in on this, then fine. At least
those are actually one of the few things that even Answers and Genesis will say. Yeah, those are fraud. Those are fake, basically.
Yeah. I mean, look, if you're gonna be, what is it? Consistent. If you're going to be consistent with it, then by all means. But you can't take one without the other. So anyway, I really like this paper. I just thought it was really cool, something to show. So, all right, we get on this one.
I believe so.
All right, so the sister group of the ceratopsians, the Pachycephalosaurs. So interestingly, the earliest Pachycephalosaurs are in the early late Cretaceous, and
the head-butting dinosaurs.
They probably did not actually butt their heads. The bone was probably not tough enough for them to butt, but that was a meme in dinosaur books for a long time. But more recent sort of morphometric studies are like, yeah, probably not. It's probably more for sexual selection.
So is this like
Although I have seen that there were injuries to the heads, or maybe they were unrelated injuries to the heads, perhaps.
Perhaps, yeah.
So is this the type of, like, this was one what they call the Hogwarts dinosaur that named after?
Yeah, Dracorex. So funny thing about Dracorex. Well, first I want to say Wananosaurus is the most basally derived Pachycephalosaur that we are aware of, and it has a very, very low shelf compared to like Pachycephalosaurus.
Yeah, it's also almost a frill, if you can see there.
Right.
Rhinoceros, yeah.
Yeah, it's almost a frill, so it's very curious, but also kind of what you expect if common ancestry is true. So yeah, Dracorex, Stygimoloch, and Pachycephalosaurus. So these were once considered three separate genera of Pachycephalosaurs, but they were all living in the same time in the same place. And researchers kind of came along later and were like, hey, I think these are ontogenetic sequences of the same dinosaur. And it turned out, yeah, they are. Dracorex has these the much more frill or much more horns, and they sort of shrink down over time, but the dome gets taller, and so it turned out, I mean, there are lots of animals that go through various ontogenetic shifts, so why should dinosaurs be any different? Someone did try this argument once with, I think it was Triceratops, saying like Triceratops was early ontogeny of Torosaurus, but that argument fell apart because we have both children and adults of both genera.
So is this like one of the arguments that people had? I remember a few years ago, whatever it was, that like that they thought was two different types of dinosaurs was actually the juvenile and adult versions of the same dinosaur.
Yes, that's what that is. Yeah, Dracorex is just the juvenile. Pachycephalosaurus is the adult.
Yeah.
So yeah, they were all living in the same time, same place, and actually, I think it happened with several others. I think like Prenocephal is another, which is the adult form of a couple other.
Nanotyrannus.
Nanotyrannus is another example. Which, funny enough, I think it was like back in the '60s, someone proposed that Nanotyrannus was actually a juvenile Tyrannosaurus. And so now we're kind of back there, but at any rate, so we good on these guys?
Yeah, so were these Laurasia or Gondwanas?
Also Laurasia.
All right.
Yep.
A lot of northern dinosaurs.
I believe these guys were pretty much almost entirely restricted to like East Asia and North America.
Yeah, this is also entirely. Yeah. It's also interesting to know that like at this time, the continents were just beginning to tear apart. So it's still close enough that you have often interchanging, but there is still some degree of endemism going on.
Yankee dinosaurs.
Yeah, there were those. That happens. So anyway. Okay, so now we're getting into the theropods, and I have this arranged with relation to their phylogeny. And I didn't provide a picture, so I'll have to kind of explain. So the abelisaurids are basically the last of the ceratosaurs. So ceratosaurs appeared in the very early Jurassic, and they diversified. And so you get, and these guys, because we've been talking a lot about Laurasian dinosaurs, these are Gondwanan. Very few of them made it into Laurasia.
I think I know a ceratosaur.
I think we all know a ceratosaur. Yeah. Most of these are almost all, and funny enough, he is a Laurasian ceratosaurus. That's funny. But almost all of these, and Ceratosaurus itself was from the Morrison Formation in the United States. So they moved southward in the Jurassic, and then pretty much all the ones in Laurasia got wiped out, possibly due to competition with other theropods. But Masiacosaurus is actually one of the few dinosaurs known from Madagascar. Scorpia venator is South America. And then Tarascosaurus is from the Mediterranean region. It's one of those dwarf theropods, one of the dwarf dinosaurs that ended up on an island or on islands. And that's why he's so small.
So it looks like, from the pictures at least, it might be, they might be a little inside, but it looks like the Mackie one has a little bit longer arms than the other two.
Yeah, it's often the case that like T-Rex often gets being picked on for having small arms, but with these guys, the arms were like ridiculously atrophied. Like they couldn't even move them. Like T-Rex could actually move their arms pretty much. Like they actually were quite strong even in T-Rex, but these guys, they were like just flopping around basically.
Carnotaurus. I think in the movie, in the dinosaur 2000 movie, the Carnotaurus can actually move their arms, but they would not have, if I remember correctly, but they would not have been able to because you see with all these guys, they're very teeny weeny arms.
Yeah, so I think also you couldn't all the fingers were almost gone, even some of them at least.
Yeah, little nubby fingers.
Yeah,
which is it's funny because theropods drop fingers like crazy. The freaking Alvarez-saurus had like one finger on a hand. It was weird.
Oh yeah, and they were actually anteaters. It turns out.
Oh god. Coelurosaurs are weird. They're bonkers. Yeah. So The abelisaurs were the last of the ceratosaurs. They made it all the way to the end Cretaceous, but they were Gondwanan predators. So good on that. Spinosauridae, pretty much only their heyday was early Cretaceous. Only Spinosaurus made it into sort of the early portion of the late Cretaceous. You have Baryonyx from England. So again, these guys are also largely Gondwanan, mostly from South America and Africa, with a couple of exceptions. But these guys are strangely enough very basally diverging members of Carnosauria. So you have like the two. So within what is it, Avitheropoda, I think you have the two major branches, which are Carnosauria and Coelurosauria.
Yeah.
And we'll get to the Coelurosaurs later, but the
That-
Carnos do
Oh.
it.
There is like some. I have seen some disagreement about the exact topology, but of course, what you said is mostly correct.
Well, yeah. So the Spinosaurids were until relatively recently considered to be megalosauroids, but it turns out they are maybe even more basally derived than the megalosauroids. So what that means is they basically branched off somewhere in probably the early Jurassic. We just don't have fossils of Spinosaurids in the Jurassic yet, but Fossil Genie is, hope to the rescue.
And these were the dinosaurs everyone hated in the third Jurassic Park movie.
Oh yeah.
Yeah, so they would definitely not have squared up with T-Rex for several reasons. One is that jaw is definitely not strong enough to bite another large theropod. They would have snapped. These guys were fish eaters. Spinosaurus, the gait of Spinosaurus was totally different. If you want to start a fight on Twitter at any point, just say Spinosaurus, and all the paleo Twitter people will start throwing hands. Because
Spinosaurus, controversial opinion. Spinosaurus would have won the battle with T-Rex.
Right.
Of course, false.
And also, of course, Spinosaurus and T-Rex lived in completely different continents. Spinosaurus lived in Africa, T-Rex in North America, and they lived millions of years apart. We're talking early Cretaceous versus the very end of the Cretaceous. So, highly diverging in time,
they were still
place.
Neat. Yeah,
they're both very neat. Yeah.
Very interesting. Like one of the unique aquatic dinosaurs as well.
Yeah, the reconstruction there of that Spinosaurus is based on a relatively recent paper that came out that maybe the tail of Spinosaurus was kind of like a newt or I have Darwin and axolotl, and so it's very curious. They could walk on their hind legs, so they were at least partially bipedal, but they probably did spend a lot of time swimming. They're very well adapted for swimming.
Yeah, although there's also one other paper that says like. A bit back, like the paper that showed this unique newt tail. They argued that Spinosaurus was a pursuit hunter. They would actually actively swim towards their prey. But then another paper says no, they are not capable. Like they were capable of swimming, but not pursuit swimming. Yeah.
Sure. Yeah, like a crocodile. Yeah.
And was the cell like later versions of the Spinosaurus or earlier versions?
So the earlier versions, and I believe the very earliest skeletons were like lost during World War II as a result of bombings in England, or like the British Museum of Natural History. And so later more skeletons were discovered, and the idea of this like half moon sail was not entirely correct. It was more this weird sort of shelf. So, dinosaurs are weird. Are we good on this one?
Yeah, I believe so.
All right. So, Carcharodontosauridae. So, yeah, if the megalosauroids basically, I think largely died out by the end of the Jurassic, but the Allosauroids, who were big players in the Jurassic, they kept on trucking into the early Cretaceous. Acrocanthosaurus from North America, Concavenator from Spain, and Xiaoqilong from China, or from Asia. Really.
Concavenator was named by Professor Dovenschmidt.
Nice.
I've never. That was a joke actually. That was a joke. Like, do you know Phineas and Ferb, the show? Like the
I'm
Professor
sorry.
Doofenshmirtz?
You you got me. You got me there.
Damn
I'm
it.
sorry.
Went over my head too. Don't worry.
Yeah.
I was just like, oh, you just know that off the top of your head. All right.
No.
Okay. That's right.
Professor
Yeah. The
Doofenshmirtz,
Innator.
Innator.
Yeah, Doofenshmirtz. Yeah. Doofenshmirtz. Yeah. The Concavinator. Yeah. He would have liked that one. So these guys, these are the Allosaurids. They're also, and so these guys are Laurasian. The two groups. The other groups of Carnosauria are predominantly Gondwanan, but these guys are Laurasian. But something happens. There's a Middle Cretaceous extinction event. And so the Silurosaurs, who had been sort of background smaller predators in the late Jurassic and the early Cretaceous, suddenly they can rise up like the proletariat and seize the means of carnivorous production. So
seize the means of consumption, or
the means of consumption. Yes, there you go.
So the Jurassic Cretaceous extinction was a few million years late.
Right. Yeah, I guess. Oh, I mean, it kind of depends because like the stegosaurs and most of the sauropods went extinct in the early Jurassic, but the big theropods from the Jurassic kind of went extinct later. Yeah. So yeah, it really sort of depends. And that's also why, as Colton mentioned,
the angiosperm sees the means of production. The
the angiosperm sees the means of production. The means of consumption. I'm going to start using that.
So did this have a name? Did it have a name or just middle?
It's just the Middle Cretaceous extinction. That's really it. It's just kind of an event. I believe it was a global warming event just by the Middle Cretaceous. Probably some volcanism going on. The Carcharodontosaurs were displaced in Laurasia, but this did allow the Tyrannosaurs to get large. So I actually have two. I kind of cheated here. Guanlong and Dailong are both from the late Jurassic, but Eotyrannus is early Cretaceous, and then by the late Cretaceous, you get like Tarbosaurus and Daspletosaurus and Tyrannosaurus. You have these guys who were little Silurosaurs in the late Jurassic and in the early Cretaceous. And they just got beefed up because suddenly the big predators were gone, and they filled that niche, and they did it very well. So they did it for like 30 or 40 million years. So yeah. So we good on the Tyrannosauroids?
Yep.
I think so.
All right. So getting closer to the birds, these are the Ornithomimosaurians. So they were the ostrich mimics, or sorry, the bird mimics. You had the Struliamimus, which was the ostrich mimic. Pelecanomimus had this cool little pouch on its throat, which Pelecanomimus probably would have been preyed upon by Concavenator. They were the same formation. Now, Dinocyrus is a weird guy, probably an herbivore, but the only remains of Dinocyrus that were known for decades and decades were just these really long arms with these super claws on them, and nobody knew what the heck they belonged to until I think the late 90s or early 2000s. They finally found a full skeleton of Dinocyrus, and they were like, oh, this is what it belonged to. So
it's even weirder than we thought.
It's even weirder than we thought. Yeah, it's this weird camel-humped ornithomimid. Yeah, super weird.
So these are closer to the bird, but they're not flying yet.
No, feathers are around, and feathers were on the earliest Tyrannosauroids. Sorry, like Dailong and Eotyrannus.
Yeah, probably not the feathers that you think of. Like when you think of feather, you mostly think of like a double-veined flight feather. Right. But the Tyrannosaurus mostly had like fuzzy fluff, basically.
Like baby down feathers, maybe.
Yes. Like that. Yeah. The flight feather, the pennaceous feathers were evolved in like the paraves.
Yeah.
So like dromaeosaurs, troodontids, and birds, and then birds are essentially only distinguished by their capacity for flapping flight. That's it. That's really it.
I think didn't Ornithomimus also had like these big feathers on the arms too?
Yeah,
like,
some did. Yeah. And so there is some record of feathers in ornithomimids. So they were also
on
probably
the
doing
arms, like on the arms, like they have wings basically, but of course not for flight, but maybe for display or something like that.
right. Yeah, they're probably waving their arms.
And like, you can also see that here, like on Dinocairus, these feathers on the arms. Yeah.
Yep. Exactly right. Therizzinosauria. If you turn your attention down to Bpiosaurus down in the bottom right, if you look at its hip, the ischium and pubis are sort of almost in the bird position. The front one, and I can't ever remember which is which, but the front one is like in line with the legs, which is not what the early condition was. The early condition was that bone was pointing forward, but now it's being pushed way back. They're almost in the. It's like sort of transitional between the lizard hip and the bird hip, and that's what you find in the ornithomimids and the therizinosaurids.
Yeah. So these were longer neck ones.
Yeah, and these guys also had these really freaking huge claws.
Also herbivorous mostly, and maybe this was the reason why they also had these transition to a bird hip condition as well.
Yep, herbivorous. Probably the claws would have helped with defense because they lived in or at least Therizinosaurus lived in the same area as a Tarbosaurus. So you could definitely envision some interactions between them. But yeah, super weird bipedal herbivores with giant claws. The late Cretaceous was a weird time. Nemongosaurus was also from Asia. I think actually Therizinosaurids are like strictly Asian. I don't think any of them made it to North America.
Like, except for a few of these, a lot of these things are northern dinosaurs. There's very few.
Which is funny because the very first dinosaur remains are found the very earliest ones are found in South America. The Ishigualasto, I remember correctly. So, are we good on the Therizinosaurs?
Yeah. Yes.
Oviraptorosaurs were getting very close. So these guys were the unfortunate subject of a meme that persisted for a very long time. Their name is literally an accident. It's Oviraptor, which means egg thief. But these guys were probably not egg thieves because they were the very first specimens were found atop a pile of eggs, and the paleontologists thought, oh, they were stealing these eggs, and then they got collapsed on by a sand dune. No, they were protecting their eggs.
Fun fact, when I took an Age of Dinosaurs courses, like a course a year and a half ago, we had to do one essay on a specific goof up in paleontology, and this was what I chose. Why oviraptors were not egg thieves.
Awesome, yeah, absolutely.
And did you piss anyone off?
No, my professor actually liked it.
Yeah. These guys are the real Maiasaurus of the world. Oviraptor was the real Maiasaurus. But yeah, you're absolutely right, Colton. They got a bad rap, and they were the egg thieves for a long time. But they're probably acting like modern birds do. They sit on their nests and they brood. Because we're getting very, very close to birdie at this point.
So some of them actually are confused. But like Caudipteryx was once thought to be an actual bird.
Yep, exactly right. Yep.
So do these still have teeth, or they were trying to get the beak forms yet?
Yeah, actually, teeth were lost in birds later. Once you get Archaeopteryx had teeth, and Hesperornis and Ichthyornis, they all had teeth. It wasn't until later that
some of these were also toothless as adults. Even I think some of them had teeth as like tiny hatchlings, and then later they lose their teeth. So that probably indicates some shift in their diet as they grow up as well.
Sure. Yeah, absolutely. We good on the Oviraptors?
Yeah. Believe so.
Yep. The poorly named Oviraptors. Troodontids, which, funny enough, Troodon may not be a valid genus anymore, even though it's like one of the most well-known and oldest dinosaur genera, might not be valid because it's based on a tooth, which I
can say, is that like one of those things of it was named first, so now we're stuck with that name?
Yeah, if in the rules of nomenclature, if you name name something and someone had already named that thing. You have to go with the first name. So I think the true name of Troodon now is like Stenonychosaurus. So
Luckily, this didn't happen with T-Rex. Because T-Rex, Tyrannosaurus Rex would have a different name, right? Because
like Deinodon. There was another one, something Spondylus. But yeah, there were several names because Barnum Brown found the first or named it first, and then I think like Cope and Marsh were naming it also, and they were also like Deinodon and these other names. But it's like nope, sorry, Tyrannosaurus already there.
Yeah.
So, Zhenyan Hualong was a dinosaur we referenced in a video on Do Dogs Come from Non-Dogs?
Right.
So we talked about birds when we were supposed to be talking about dogs. And the point we made with that was if you're a person who is averse to facts, you might think, and you think evolution is wrong, try figuring out which of, is Zhenyan Hualong, is that a bird? Is Archaeopteryx a bird? Is Microraptor a bird? And suddenly it's really hard to figure out which is a bird and which isn't a bird.
Yeah.
And in fact, if you follow Answers in Genesis, they have thrown in the towel and they say that the dromaeosaurs are birds. So
yeah, I don't know if you remember when there was like a G plus thing. Like I actually posted the paper from which Zhenyan Hualong was published, and I also included that very image. But I pissed some creationist off who says like, "Oh, that's just a drawing." Oh, I don't know. Here is the actual fossil then, and then never came back to me. The fossil, yeah, it's very weird.
So that could be a future spin-off of that series. Do birds come from non-birds?
Well, we did a whole series where we talk about the evolution of dinosaurs.
Yeah.
So I think we've already done our birds from non-birds series. Then me. I love that like one is Zhenyan Hualong and the other is just me, which means sleeping, because the genus Me Long, sleeping dragon, because they were found curled up. They had been suffocated by nearby volcanoes. So interestingly enough,
the top left one was like a mini chicken.
Yeah, probably. Yeah. It sort of looks like a little mini chicken. Byronosaurus also. These are all. I think most troodontids were Eurasian, but like a few straggled into North America. They're predominantly.
I think the top right is a bit like it's almost naked, or it looks like it is naked, like the top right. Although, its fluff isn't very.
It's
thick,
not
like.
It's kind of shrink wrapped with. It's got the feathers, but it's still kind of shrink wrapped.
Yeah, I know. And I think the top left is the best depiction of how it would look like.
It is.
It would be really fluffy. Yeah, it was really fluffy. Yeah.
Yeah, it is.
It's
pretty adorable.
Like it's the agonist from Despicable Me. It's so fluffy.
Right.
So,
yeah.
It's fluffy.
We get on Troodon. Oh, sorry.
So were these flying yet, or
no? Probably not.
Okay.
Probably not. When we get to the next slide, we'll talk a little bit about that. So,
all right.
Okay, so Dromaeosauridae. So now we are almost birds, and now here's the really interesting thing. There is some debate now as to whether the common ancestor of dromaeosaurids and birds was in fact capable of flight, but lost it later in dromaeosaurids, but retained it in birds. And so part of the cool thing is you have guys like Microraptor and Chainuraptor who are basically quadrupedal gliders, and Archaeopteryx was not a very good flyer. It was like hard flapping it to get a little lift.
I think it's like Microraptor they weren't flying, they were more like gliding.
That's what I said. They were four-winged gliders.
Oh, gliding. Oh, sorry. That's flying.
So you could kind of think of them sort of like colugos, which are mammal gliders. They have this membranous skin that they stretch. Although, fun fact, there's a super weird group that's only been found in recent years, which were like bat-winged theropods.
Oh yeah.
So that's really weird. Another little niche that.
Forgot to include the slides.
I did not. Yeah, I didn't include them because I don't even remember what group.
The Scansoriopterid.
Oh, you're right. Yep, you're right. Although that's another group that keeps flipping back and forth as to where it goes, because in some they're like fairly low in Maniraptora, and some they're like sister to birds. So they just keep jumping back and forth.
And there are some of them like close to Oviraptorosaurids. Like they are a weird group, like very derived and not very like. We need more fossils to exactly nail down where they belong. Yeah,
right.
I forget where I heard it from. Wasn't there like wasn't there like a naming thing? Controversy with Microraptor, like someone thought of it a long time ago, and
Tetrapteryx, yes, yeah, it was predicted by William Beebe in the early 1900s. He looked at I think it was the like feather quills on the legs of like embryonic pigeons or whatever.
Also Archaeopteryx also had like it also had like not very big, but they still had feathers on the legs too.
Right. Yeah, they develop like birds will develop these feathers embryonically, but then they get like subsumed back into the body, and the early birds had them, and so he was like, it makes sense they probably went through a quadrupedal gliding phase, and wouldn't you know it, we found a bunch of quadrupedal gliders close to birds. So who would have thunk it? And Halscaraptor was found in I think 2019. It's a weird little guy. It's kind of like it was like a semi-aquatic. It was weird. So kind of like a goose almost.
Like the early like the dinosaur versions of penguins.
Yeah, it maybe more like geese, I think. With that long neck. But yeah, it's a weird guy. It's a weird little dude.
There's also like about the possibility of the common ancestor between birds and dromaeosaurids to be like it may be gliding. It's also an interesting possibility because it like the juveniles of like Velociraptor and such, they could have started out as maybe gliding, and then as they became adults, they became more cursorial, right? Because of because they were heavy as adults. It's also an interesting possibility to know. Yeah,
there's some sort of hoax in 1999.
Oh yeah, they did National Geographic thing with Microraptor. Yeah.
So the
Archaeoraptor.
Yeah, the funny thing about Archaeoraptor is it's actually part Microraptor. So if you actually look at the fossils themselves that make up the Archaeoraptor, they're really interesting. But also the color of Microraptor there. By the way, I actually met one of the paleontologists who debunked Archaeoraptor. It fooled no one. It did not fool a single paleontologist. I met. Oh crap. Oh, I can see her face. Can't remember her name. Sad. But I met her, one of the paleontologists, American woman. She came to LSU Baton Rouge and gave a talk. She was a really cool lady. She figured out the color on Microraptor because it was preserved. A few of them have been preserved with melanosomes, and it turned out they had this iridescent black feathers. It was really neat.
This picture right here, it's actually what it would look like. Like Psittacosaurus.
I can't. She also named Vega Avis. If anyone can figure out, hold on.
Name.
I have it right. Clark. Yeah, Clark.
Yeah, there was this guy who purchased this fossil from an illegal salesman, and he was like, "Oh wow, what an interesting fossil! I will buy this for like $80,000." And he goes around to expert, and every one of them tells him like, "This is a fake."
Julia Clark.
Of course, the guy doesn't accept the conclusion of the experts because he was duped.
It was even funnier than that because Dr. Julia Clark was her name, and I met her. She's a cool lady. The funny thing was he's like a Fiducia fan, and so Fiducia takes this really bizarre position that birds, not just birds, every feathered theropod forms a group sister to the dinosaurs, and their dinosaur characteristics are only secondary. Or convergent. It's really, really bonkers and backwards. But that guy who bought it, I think his last name was Zirkus. He was also, and he has like his own museum, and he's on that train. Same as David Peters. He's also on the Fiducia train. But
doesn't David Peters also think that birds are descended from pterosaurs, right?
something like that. He's also crazy. He uses like low res images to build phylogenies. It's very funny.
Also,
He's crazy guy.
I have noticed you often, not often, but sometimes you use his pictures from Google Images.
Okay.
I don't anymore.
Yeah.
I have been. I try to avoid that as much as possible. I did that a long time ago, and then when I found out about him, I was like,
Oh shit.
never
Damn.
again. And
So,
the skeletons I have used, like Bpiosaurus, not his. I think I used Iguanodon, was also not his.
Yeah.
But yeah. So I try very hard to avoid that because he is prolific. His stuff is everywhere.
So these
You cannot
people,
escape.
so these people aren't creationists, but not still not with the scientific thing.
I mean, because like at one point it was okay to defend the idea that birds are not dinosaurs. Like before we had a lot of the fossil transitions and the embryonic data, you could reasonably defend that position. You really can't anymore. So
Fiducia's just invested so much time into it that he's just fully suffering from the sunk cost fallacy.
yeah,
That's my
I
take
actually
on it.
I know I think you're right. I do think you're right. And funny enough, actually, when I worked at the Museum of Mammalogy, Museum of Zoology in the Department of Mammalogy, I would actually put my backpack right next to like Fiducia's thesis. It was on the shelf, and so yeah, he went there for a time, and so I think he actually got his thesis at LSU Baton Rouge. But regardless, yeah, I think Colton, you're right that he's in his 80s. He's in his 80s at this point, so he's it's whatever.
Your backpack includes like books on dinosaurs and how dinosaurs evolved into birds, and you were like you feel this. This is the weight of the evidence that you deny.
Pretty much, yeah. It's yeah. There's still a few people who publish stuff with him, and it's like you guys are not helping yourselves. You're not helping yourselves out here.
Is he the only guy left, or are there still also a few other guys?
Of the bandits? Yeah, there's like 4 or 5 who still publish stuff with him occasionally, and it's just like, good lord, guys, get over it. Anyway,
did I ever tell you the definition of insanity?
Right.
It's repeating the same stuff over and over again and expecting different results.
Just because it's the consensus doesn't mean it's right. Yeah, but that doesn't mean you're right because you're in the minority.
Honestly, yeah. And so finally we get to the birds. So like we said, the very few characteristics separate birds from dromaeosaurids and troodontids, which is why the phylogeny of paraves keeps switching around. They're that close to each other. And so you get all these birds had teeth in Enantiornis, Ichthyornis, Hesperornis, Confuciusornis. All these guys had teeth. Teeth were lost later towards the crown aves. Enantiornis is named for they have this their shoulder bone, I think, is pointed opposite.
Yeah. It literally means opposite birth.
Yeah, I think it was one of their shoulder bones was like pointed the opposite direction. Yep. Hesperornis was kind of like a penguin, sort of, but like a 6-foot penguin, so sort of similar.
Yeah, and it's also interesting to note that the Enantiornithines were the birds that were the most dominant in the air, while the crown group birds, like the birds that are the ancestors of today's birds, they were on the ground, mostly.
Right. Yep. What were you saying? Lamont? Did you ask something?
Oh yeah, I was about to ask the few, like the hold off of the extinction event. The terror birds, were they true birds or more basal birds?
They're aves. They are. I can't.
They are crown group birds. Yeah.
I think they're paleognaths, aren't they?
No, the terror birds not. No.
Oh, maybe I'm thinking of the elephant bird. The elephant bird was a
the elephant bird.
paleognath.
Yeah, they were. Yeah.
Yeah, I don't remember. Okay, I don't remember what the terror birds were then. I don't remember.
Like the terror birds were closely related to the Serianas, I think.
Okay.
It's like a bird in South America. Also a pretty rare bird. But yeah.
Oh, okay.
It's a very interesting relationship. Like it's part of the neo aves, of course. Like the 95% of all birds. Like it's. Of course, that's after the Cretaceous, Please stay
Right,
in the
yes.
Cretaceous.
Yep, that's
Yeah.
Cenozoic.
Yeah.
Of course, you got to. The dinosaurs, they weren't gone; they were just knocked down. They were still, and I mean, in South America, the terror birds survived to like the Pliocene. They were around for quite a while in
Yeah,
some places.
until they decided let's just do cut in North America. Let's see what's up there.
Yeah, so
Nothing good.
Yeah, and then they ran into Smilodon.
Yeah, well, in fairness, I mean, marsupials didn't do too bad for themselves. I mean, yeah, they did suffer as a result, but also the Virginia possum is very prolific, so they did okay overall.
Yeah, they are possums. Yeah.
Yeah.
We have the Ohio possum up over where I live.
Right. Yeah.
Like they can reproduce really quickly. Like they wear their children as clothes on their bodies, basically. They are entirely covered.
And that rumor is really true. Cause when I was little, my dog tried to attack a possum and it just laid there.
Well, yeah. I mean, playing possum. Yeah. What is it? Gopher snakes, I think. They do it too, where they just like flip themselves over, pretend to be dead. So yeah, there's a couple of groups who will.
You're also thinking
possum.
of hog noses.
Hognose, yeah, sorry, hognose snakes. Yeah, there you go. Thank you.
The only marsupial that decided not to go to Australia.
Well, there's actually a lot of marsupials in South America, like Manito del Montes and different little guys. Yeah, there's a bunch of groups. Funny enough, actually, the relatives of the Manito del Monte have been found in Antarctica, which is how we know that's how they transferred through there instead of across Africa.
But they're probably not still there. I don't think.
No, they're long gone. Yeah.
That'd be cool if there was a marsupial that adapted to Antarctica.
Oh, at the time it would be still.
It was tropical.
Tropical, yeah.
Yeah, that was only like Paleocene, Eocene, and I think in the Oligocene is when they finally break off and the currents start circling Antarctica and it drags the temperature way down. So birds.
Also, real fast, like more geology thing. Apparently, Antarctica isn't really a big continent. It's more like archipelagos. I think someone said once.
I mean, there are archipelagos around Antarctica. There's like the
Vega
Island.
I think if Antarctica would be entirely like melted, it would be mostly archipelago. I think mostly.
Oh, if it were melted,
Yeah.
maybe I don't know. It's possible.
Yeah.
It's entirely possible, I suppose. All right, so we done with the dinosaurs?
Yeah, I believe so.
All right, so now we tackled the mammals poised for their takeover of the Earth. The meek shall inherit the Earth, and so they did. Raphinomammus was actually about the size of a badger, and it's eating a Psittacosaurus in that picture because it has been found with Psittacosaurus in their gut. Simolestes was a little group of true mammals, and I believe eutherians. But they sort of straggled the line between late Cretaceous and early Paleogene. Taniolabus was another group, was part of the multituberculates, named for the tubercles on their teeth, and they also straggled from the Cretaceous into the Paleogene, but they went extinct in the early Paleogene. And then Eucatherium or Eucatherium was another mammal which went extinct in the late Cretaceous. But so the mammals, it's really neat in my opinion that not the groups so much that go extinct, but the ones who actually survive the boundaries.
And you see even they looked very similar back then.
Yep, kind of shrew-like or badger-like.
Yeah.
They're not. There's a couple weird little guys here and there, like Castoricata from the late Jurassic had like a beaver tail. And I think there's been some debate as to whether was it Velaticotherium was like capable of gliding, but but mostly shrews.
Like idiots like Nephilim 3 would like to claim that beavers were there because of Gastrocuda.
No, not a beaver, but sort of like a beaver, hence the castor part of the name.
So are these all placentals, or some of them marsupials or monitoring ancestors?
Also various different groups, yeah.
these guys represent different groups. So they are mammals, but I don't think. But whether or not these guys are all eutherians, I think some of them are. Like this, I think Cymolestids and the multituberculates, I believe, are both eutherians.
No, multis are not eutherian.
They're not. Okay. So yeah.
I think they are outside eventherian. Like multis are like marsupials and placentals are closer together, and then you have the multis, and then later you have of course the mountains. Yeah.
Oh,
I gotcha. Okay, but they all fall within crown mammalia at the very least. But whether or not they are, in fact,
so we don't know if these were still egg laying or they live birth yet.
Again, it depends. It depends on which group you're looking at.
And it's of course interesting. Like it's difficult to tell, of course, because it doesn't fossilize. But based on the phylogenetic bracket hypothesis, then they could maybe still be egg laying. Some of them, like the multis, could still be egg laying, maybe or maybe not. Yeah, it's uncertain.
Right. Yeah. Yeah. Absolutely. Yeah. So, and then that's the end for me. So I'm going to stop sharing. We've
nice. So we talked about the two. If we go, anybody in the audience have any questions? Or I mean, real questions, not stupid questions, like Inca stones and stuff like that.
Colton, do you have any questions?
No,
I've got a question for you, Colton.
Oh boy, lay it on me.
Why?
Why what?
Why? Just why?
Come at me, bro. Come at me.
Look, man, I've already told you it had to be done, okay?
It had to be done. I don't know. I think it's interesting that there's like with regard to the ceratopsians, like the very first ones appear in Asia,
Bisons.
and then bisons, right? And then you have like a gap in Asia because it's like they kind of moved to North America and then like back, or some of them moved back, some of the larger guys. So I think that's kind of interesting.
They were like regular tourists,
right?
Like going back and forth. Also, James says in the chat the mammal origins had occurred way earlier in the Triassic. Yeah, but yeah.
Well, yeah. But I mean, they were still egg laying back then, like a Ligocyphus and the
when did the crown group of mammals begin? I don't know.
That's like right at the, if I remember correctly, that's like right at the boundary between the Triassic and Jurassic. Is when you get
the common ancestor between the platypus and us.
Yes.
Yeah.
Yep.
Of course, like many people or many researchers will say mammals or apply the name mammal to even beyond just the crown group. But yeah.
RJ, that is a silly question. At any rate,
so you guys have anything coming up on your channels that you want to advertise here?
Colton?
No.
I recommend Jackson's channel because he does the work and more interesting regularly publishing the videos.
So
I don't
Jackson,
really have a channel, yeah.
So Jackson, are you only concentrating on the stories of the ancestors' tales? Everything else coming up?
Presently, yes. Still waiting on one little thing to get finished, but yeah, by and large, as Nestle knows, we're doing the Ancestors' Tale series, and we've got like 55 videos in that series left, something like that.
Yeah, you haven't even got to the non-human.
Well, because it's not even because the new version, the second edition, has even more tales than the first edition did. So it's got like 60 in total, whereas I think the first one had like 40 or so. So yeah, it's ludicrously long.
Rivaling the chimps and bonobos.
Yeah, we're not even to our next living relatives yet, and we're five videos deep. So
what's the last in the series? The Ancestors Tale?
The previous one we did, or the very
last
in the whole
last
series
on the list, the whole series.
That would be it's a bacterial tail, so you get either tax tail, Thermus aquaticus, or Rhizobium, because those both have tails but I don't remember which is actually the last one.
I think I remember every one of those is about the wheel, like the bacteria wheel.
Yep, that's hold on. No, that's the Mixatrix tale. That's in that's the
That's the one where they talked about how the ancestors of what in the symbiosis, where they talked about what we thought were actually parts of the eukaryote were actually bacteria attached to the eukaryote.
That's part of the Mixatrix tale. Because you have bacteria on bacteria on bacteria. It's very funny because you have like the termite, like Mastotermes darwiniensis, the Darwin's termite, named for Darwin, Australia, which may be named after Charles. Not sure. I don't actually know. But you have the termite, and within its gut, the thing that actually does the cellulose breaking down is a protist, sorry, called Mixotricha paradoxa, and it has these little hairs on it which look like cilia, but aren't. It's two different types of bacteria. One actually forms like the little base, and the other is like the cilia itself. And so you have this bacteria on a protist in a termite.
So this is like maybe like
Inception.
So this could be like pre beginning of what later became endosymbiosis, maybe.
Maybe.
Maybe. Yeah, maybe. At any rate.
Well, for me, next week at this time, I will have Dan and David on, and we are going to be debunking all the COVID vaccine myths that are going out around.
Thank God! I will tune in for that.
That's a lot. There are a lot of
like the reasons why people are still being are holdouts. Besides not having vaccines in their country or something, why they're not getting vaccinated.
I can't like we did a video on the vaccine thing too, like Jackson, and I included the line of a news article that told the experience of a healthcare worker taking care of someone who denies the virus even exists, and he was like deadly sick. Like, can you imagine taking care of somebody who denies the illness that they are being
One of the
treated
saddest
for?
things I read was there are people who, when they come down with really bad COVID cases and then they have to be put on ventilators, they will beg before they're intubated to get the vaccine, and all the doctors can go is like, it's too late. It's too late for that. I mean, we can't help you.
You had your chance.
It's almost morbidly funny that it's very quickly morbidly humorous that the group most susceptible, or one of the groups most susceptible, is the elderly, who also many of whom are like, the vaccine is a hoax, and it's trying to brainwash us and all this nonsense. Them and the other group are like the people who really can't get vaccinated.
They're the same type who always say do your own research, but I'm not taking research advice from somebody who texts me how to open PDF.
I'm also talking about like an extreme case where like you also have the examples of like when they get infected they will say, oh, please give me the vaccine right now. But they have also other cases where they are dying and they will say like, no, it can't be COVID, it must be cancer.
I understand it. I mentioned this last year. I understand it's the people that think my body can handle this virus. My body is strong enough to fight it. The people that want to say don't believe in evolution usually, but they're really what they're fighting on is natural selection for us to fight the virus ourselves, and natural selection to weed out the people. But we've moved beyond on that.
I mean, the people. I mean, you're right. You're right, Lamont. The people who say I'm strong enough to fight it, it's like, you guys weren't around when like the population was ravaged by measles and smallpox and all these other things. Clearly, our bodies could not handle it, which is why we made vaccines. It's like, you guys really don't understand how vaccines.
Well, I mean,
work.
look, sure, maybe it's like a 98% survival rate for COVID, but polio was up to 95. 95% of people with polio would survive. That wasn't the point.
Yeah.
Preventing deaths was not the point.
It's also the case that many
probably a
people
lot of people.
survive COVID.
I have a friend's mom who survived polio, but it doesn't mean her life was great afterwards. He still can't walk very well, and at least he survived. That did the iron lung thing.
Yeah.
People
people who have gotten infected with COVID also have permanent lung damage, and also heart damage. Even it's crazy.
Yep, it's all a hoax. Sorry, guys.
Yeah. My friend got COVID and still can't taste very well stuff.
Yeah. At any rate, we've been going 2.5 hours. I'm sorry, I took a very long time in my presentation. Colton's was nice and sweet. He had this great summary, and I was like, no, we're going all out.
There you go.
Yeah.
But you know what you didn't talk about, Jackson? You didn't talk about the plants, but you told me you were going to talk about the plants. You lied.
We did talk about plants.
we
talked about the angiosperms at the very beginning.
Flowers aren't plants. Okay, look, let's be real here.
We didn't talk about. We talked about the. We didn't talk about very much. As maybe you rephrase it a little bit. We didn't talk about the insects very much, and the bug life.
Early ants, early bees in the early Cretaceous. You had Spicamirma, which is like an ant wasp, which is really cool, and you had a Melitospex, which is a bee wasp, and these are showing up right around the time we're seeing the first flowers, which Kelsapries, right?
Also beetles and butterflies, but if we went on them, then we never finished this this talk.
I didn't want to go. I kind of glossed over it with like the Cretaceous terrestrial revolution. You have the arthropods, then mammals, then theropods, and so you have these radiations within radiations, which that was about as close as we were getting, because otherwise we'd never get to
Yeah. So y'all want to? So Jackson, I know Colton doesn't have one, so you want to say your ending catchphrase?
Thanks for watching, and we'll see you next time.
All right, and never stop learning. Enjoy the randomness. See you next week for the virus debunks. Bye.